technology. Now we are on record. I'm going to start, guys, by, like I said, I look at the electrical industry from two eyes, electrical engineer and electrical designer. My background is power, so power engineering. So I worked on hospitals, sport arenas, designed the power system. So switch gears, switch boards, that's kind of my bread and butter. I know you guys, and this is not what you do, but this class is geared towards what you do. So I'm not going to gear it towards switch gears. I do have a lot of toys with me here that you guys have seen, and based on 3M, you are to use some of these toys based on the hazard involved in the area that you're working at. So what I did, guys, I have a few things with me. Like I said, the first thing is this is the hazard review record. I'm sure it looks familiar to you guys. This is yours. This is 3M, and we'll go over this one, later on, and that's why you guys are here in this class because of that hazard review record that you have to do for all the work that you do. I do have the PowerPoint presentation. You guys have a folder like this, which has a PowerPoint presentation. Feel free to write it in it. So that's what we're going to be doing also. I do have a quiz. You guys have the quiz with you. So this is right in here. This is my quiz. That's the quiz that you guys will be taking later on. So you can keep track. It should be in the package that I gave to you. I need this with your name on it when you give it to me. That's one of the things I would like to give back. You guys also have an evaluation sheet. Also, I need this evaluation sheet from you and the signing sheet. The signing sheet is right there. Signing sheet, evaluation sheet, and the quiz. That's I need. Everything else you can keep. We do have activities for you guys, so you know the class was going to go. We have three activities. So make sure you have activity 1, activity 2, and activity 3, right? So that's, if you don't, let me know. Activity 1, activity 2, activity 3, quiz, evaluation sheet, and the PowerPoint. So that's, you should have these stuff in front of you. Okay, so that's the housekeeping, a little bit of things. What I'm going to do, guys, we're going to stay here for my understanding from here until 4 o'clock. Everybody's aware of that one? This will be your electrical safety training. The way I do it, guys, every 1 hour, I'll give you 5 minutes to go out, and bathrooms are here, and stretch and do things. Otherwise, I might put you to sleep. So everybody's okay? When it's 1 o'clock, raise your hand, say, Chad, enough. We had it. So for the housekeeping things. I brought with me a few toys. I know, I fully understand you guys are not electricians, but these are really, over the years, I found them very, very very helpful. The electrical calculators, you guys do voltage drop on low voltage things, that will work too. The voltage drop, sizing, if I don't know how much you get into sizing cables and what's not. This is really handy, sizing fuses, sizing circuit breakers, so this is really, really cool. I must have, and from an engineering point of view and technician as well. This one, DeWalt, I don't know how many, you know ugly. Everybody knows ugly, right? That's 5 times better than ugly. For $19, you can't beat that one. So it has a lot of stuff for you, a lot of summary of the NEC code book and summary of standard boxes and what's not. It's geared toward electricians and electrical engineers, but you'll find some stuff that's beneficial for you too. So I always like to show you that one. The electrical safety, guys, I know we have engineers here. IEEE standard 3007. Bunch of them, I don't know how many of you guys have seen this. Put these one to talk about the electrical safety from an electrical point of view, but the focus of this is high voltage, really, 600 volt level, and even higher than that. So if anybody's interested in them, they're IEEE standard 3007.1, 2, and 3. Recommended practice for electrical safety in industrial commercial power system like you guys, but I don't go too much into it because you guys are not electricians. You guys familiar with the NEC code book? This is related to class. I believe you guys deal with class 2 and 3 circuits, control circuits, right? For the most part, that's what the lab is. So there's a whole article 725 talk about class 2 and class 1, 2, and 3 circuits. So it's really nice sometimes to look at these and see what the electricians are supposed to do and know about what you guys are doing. And I know this is mostly related to the electrical. I know, again, this is mostly related to electrical, but also to you guys. There's 70B Are you guys familiar with 70B? 70E is why you guys are here. You're here for the 70E. We're going to be doing the training based on this. So that document will tell you how to work on things energized or put things, electrical things, in a safe working condition. Either de-energize it and work on it, which is the rule, or if you are, which is the exception, to work on energize, it'll tell you what the rules for working on energize. That's it, 70E. 70B put together safety programs, and you guys here have a safety program. Part of it is the electrical component, is part of your electrical maintenance safety programs. So that will tell you how to maintain electrical power systems. Again, mostly geared towards power, but there is some stuff also about lower voltages, you know, DC and AC. So I thought to show you that one. I'm sure you guys have seen SPD. This is Busman. They put a great free, you can download as a PDF, manual about everything you need to know about fuses, electronic fuses that you guys use a lot of, peak current limiting fuses, which I assume you guys you love it too much because it reduces the energy and it doesn't burn your electronic equipment. So a lot of stuff about fuses. That's, if you want to go deeper, that's a good resource to have. Like I said, I always like to have them with me. Okay. Any comments, guys? Any questions? Before I move on, I have to warn you, I have two speeds. One is fast and one is faster. So if I get too excited, too carried away, you stop me or slow me down, right? We have 3 hours. We're going to spend 4 hours. We're going to spend 3 hours, guys, on the PowerPoint presentation and discussion. Please, I'm not an I don't know more than you guys know. You know a lot. You're in the field. You do a lot. You have a lot of knowledge. Bring it on as we go. So we're going to spend 1 hour on the activity at the end and 3 hours on the PowerPoint presentation or so forth. For the activities, guys, I have 8 modules in the back. You have 3 activities with you. One of them does not require hands-on work. The other 2 will require you to do hands-on, and I do have these suitcase in the back. There are 2 different activities, so we'll team you in teams of 2 and you work on them. Very simple compared to what you guys do, but it verifies the skills. They call it skill verification. So that's what you guys are going to be doing. Okay, so let's go ahead, and this is just warming up. So this is what we're going to be doing, guys. This is for you 3M Research Laboratory Electrical Safety Program. I'm done by Dunwoody. And if you're wondering why are you being tortured by Chad here, that's what they told me to show you guys this, because I don't think all of you are Dunwoody, are 3M employees. You're contractors. Some of you are contractors. You're here because you answered the question that you work on energized equipment. That's why they put you here. And I think everybody at one time will work on energized equipment more than 50 volts. So that's your survey. Let me grab my highlighter here. So that's if you work on energized equipment more than, and drop please the DC here. This is wrong. This is typically, if you work on anything more than 50 volt AC or DC, it's considered high volt energized. Anything AC or DC more than 50 volt. I have been told by Tim Coyle, who put it together, that you guys are going to change this. So it's more 50 volt, more than 50 volt AC or DC. If you work on energized, it's considered energized, and you have to follow rules and regulations based on that. So that's the justification for you being tortured by your friend Chad today. And of course, we do the safety because it's required by the law. What I'm going to do, guys, I'm going to go over Introduction to 70E. This is the Bible when it comes to the electrical safety. Obviously, safety, and you guys don't do, well, you do construction, right? A little bit. But in a construction or the maintenance, electrical safety is only one. I always say we, the electrical people, low voltage or high voltage, we only represent 15% of the equation. Remember, only 15. The rest is the other disciplines in the area, mechanical and plumbing and what's not, unless you guys do all of this stuff and other construction trades. So this is mainly for the electrical. You're not going to find any plumbing or high pressure or any of these stuff. So electrical hazard in the workplace. We're going to do some analysis on the electrical hazard in the workplace because you guys are doing it. We will use 3M. I'll show you guys the one that you fill when you do electrical work, energized or non-energized, justification for working energized and what's not. Electrical safe working condition. This is the rule. 70E and OSHA require you to work on things de-energized. There's only the exception, which probably you guys are the exception because you deal with a lot of process. Only the exception is to work on things energized. So remember, the rule is de-energize if you can. And if you cannot de-energize, you have to have a reason for not. We'll go over the reasons for not energizing. Requirement for energized work, if you, which you are the exception, if you are to becoming the exception and you work energized, you have to do a few things. Number one, we need to use the voltage, they call it voltage approach limits, and we'll talk, for you guys will be 150 volt, maybe 300 volts, but if you are an electrician, you're talking about hot, medium voltage even. And of course, the proper PPE, personal protective gear that you're supposed to put on you, which we talked about the gloves, and we will talk about the gloves in a second. Arc flash, boundaries, and the proper PPE to protect you from this big ball of fire. I'm sure you guys have went on YouTube. If you go to YouTube and type arc flash, electricians do that all the time. I don't know if you guys do that. And you see a transformer, bam, explode. You know, so there's so much big ball of fire. That's, I always, if anybody say arc flash, remember they're talking about a big ball of fire coming out of an electrical piece of equipment. If you're dealing with 120 volt or less in an enclosure, do not expect the ball of fire to be 3 feet diameter. Expect it to be half an inch, maybe a quarter of an inch, tiny little thing. You'll see it, guys, when you turn to, not a whole lot of big, there is a little ball of fire, but not like 3-foot ball of fire. So we'll talk about this one. Selection and use of testing equipment. The major component, guys, when we work on energized objects, on energized equipment, is to use the proper tools when you're working energized. And I'm sure you guys, I don't know, because you guys are technician, have you used the fully insulated electrical equipment in your line of work? Fully insulated. When I say insulated, these are rated for 600 volt, literally, or 1,000 volt, depending what you have. You know, so these are what energized. They look exactly like, looks for you know, for people who don't know, it looks like an insulation, but it's really voltage rated. Think about it, voltage rated. This is comfort grip, this one. So we'll talk about this one, selecting them and using them. And of course, we'll talk a little bit about GFCI. One of the line of defense from electrocution is the GFCI, and energizing anything you can from a GFCI if you can. For you guys, believe it or not, your lab is an exception to the GFCI. There's an exception in any secret book to using GFCI. Industrial labs are one of them, because if you're mixing chemicals and the circuit trip, right, you create more hazard than what you're trying to avoid. So industrial labs that can create more hazard, they're exempt in the NDC code book from being put on a GFCI. So if anybody tell you that, they said we don't want to burn the building with a chemical reaction here. Okay, so that's what we're going to be doing, guys. Topics to be covered. Power electronics. We're going to talk a little bit about power electronics. And of course, your lab, research and development. I don't know if you guys do a lot of research and development here in this lab or somewhere else, probably. Research and development, special requirement. And then we'll talk about electrical safety program. Every company has electrical. You guys have your own electrical safety program. And part of your electrical safety program to do an analysis that they have put it online for you. I don't know how many of you, the engineers, you probably guys filled it. If you are to go work in a place you are to go, it's really, I went through it last night. It's really nice, detailed on what you're supposed to do. So it document what you're doing and verify why you need to do what you're supposed to do. Skills verification exercise, and you guys have to do part of the 3M area hazard analysis that they do, guys. You're going to see later on, they'll tell you, if you do work on energized electrical equipment, you have to come and be tortured by Chad Carey or somebody else in a class like this. So you have to do electrical training. So that's part of your analysis that you do, 3M area hazard analysis, or area hazard analysis. Part of it is to do electrical safety training, and that's why you guys are here. Part of electrical safety training, when we're going to do the exercise verification, guys, very easy behind you. Verify how to use an ammeter, an ohm meter, and verify how to energize conductors, energized or non-energized. We'll go through it, very simple. And of course, we have to justify to the OSHA that you guys have gone through the training, so they quiz you. we quiz you. And the quiz, after we do the quiz, guys, we'll go over the answer. So the intention is not to quiz you to test you, is to learn from it. Okay, 70, we talked about 70E. You guys are looking at that boy. This is the most up-to-date, adopted by us here in the state of Minnesota. And basically default for OSHA electrical training. That's default, the safety training for OSHA is 70E. So that's what we're going to use it. It's done every 3 years, and this year's 2012 is the available one now. 2012 and 3 years. In 2015, next year, it will be due for a new cycle for them. So that's the standard. Of course, who does it other than NFPA? NFPA publish it, and it's called a 70E. And this is NFPA 70. That's the Bible. Here's 70E. And here's 70B. So you guys know, anybody knows where A went? There's 70, 70B, and E. Or others. So there's 70A that they have an NDC code book for residential. They call it 70E. Tiny little piece for residential only. So that's, we'll go over that one. If you guys go to 70E, I don't know how many, do they provide a copy for you guys of 70E? Do you have a copy available here? Well, really nice to have a copy. It's nice to read, I think. It might put you to sleep, but it's, well, here's what happened. Because NFPA wants to be the United States of America, they want to be standard for all the United States of America, 50 states and all the territories. People were best off at them because they sell it. So they said, if you guys want us to adopt the NDC code book as the law of the land in the state of Minnesota, which we do, it has to be free because the law is free, right? So long story short, now all their documents are available, including this boy, free online. I don't know if you guys know that. If you're interested, either you go there, I'll give you the link for it. They made it cumbersome a little bit intentionally because they want you to buy it, but you can go there and look at this document. You can, in a format, they can't copy or print from it, but guess what? Copy screen is always there, so or print screen. So, but it's available. This one, including everything, all the documents that the PA has are available online for free because they want to, because people push them. It's the law. Okay, so initiated the request for OSHA and health. So remember this one, guys, the 70E is actually the OSHA adopted default standard for the electrical safety. So 70E applies to the activities. It doesn't apply to the design, apply to working on equipment energized or putting the equipment in a safe working condition. Basically de-energizing the equipment, locking it, tagging it, and working on it. Or if you have, which is the exception, to work on it energized. So applies to the operation and activities in the employee's workplace. It does not apply to the design and installation. And the reason for design and installation, because first, when you design as an engineer, you don't touch anything. You're working with computers, right? And when we install, how often do we install a 4,000 amp switch gear 480 energized? Really? Do you install it? It'll take you forever to install if you do that. Design and installation, you're looking at, this is the Bible for design. The next electrical course. This is for maintaining the electrical system, basically, and working on the electrical system, energize and de-energize. And this document will give you how to, this is related to the safety, and this is the procedure of maintaining it. So they have so many documents that keep you entertained. So exclusions, there's some exclusions, guys, in the NDC code book. You're not interested too much in these. Ships and watercraft, if anybody be in the Navy and all this stuff, they have their own standards that they follow. And mines and what's not, and electrical utilities and communication, these are exception of these. They have their own standard that they follow in terms of safety, which we're not interested. Safety related work practice. Here's how the book is laid out. NFPA books, all of them, guys, are almost laid out the same way because they have a standard for NFPA books. It starts with Article 100, which gives you the definition. So they define what energized equipment is. There's a voltage somewhere, on it. So a definition, start with the definitions here. So if you are reading any of the documents that I mentioned and you don't understand something, assuming you you have a minimum level of technical in the field that you're in. You go to the definitions and they'll have that definition for you right there. Then the applications, how to apply them. Then general requirements, we'll spend some time on that one. Establishing an electrical safe working condition. That's where you guys come. Establishing an electrically safe work condition. This is a fancy name for putting the equipment in a safe working condition by de-energizing it and verify that's de-energized and lockout and tagout and do the lockout tagout procedures that you guys know. So putting the equipment in an electrically safe work condition, that's the term that they use. Work involving electrical hazard. Now, like I said, if, which is the exception, if you are to work on energized, then they have a whole section is how do you do work energized? How do you work on energized objects? And then they have a couple of articles, guys, about related to maintenance requirement. The PPE is right here in one whole article, personal safety protective equipment, PPE. You're looking at bunch of them here, from the gloves into the suit into the shield that you have to do. So they have a whole section about them. Then they move into special equipment, exactly like the NEC code book. These are special equipment. So most of the stuff that you need for safety is really in the first 4 articles or 5 articles. We move into these here, special equipment. They talk about power electronics, VFDs and soft starts and all this good stuff, what's inside them. And research and development labs, which applies to you guys. You have a research and development labs. So that's basically how that document, and you look at it, it's a small document, so it's not a big document. Each one of these, you're looking at 3, 4, or 5, maybe 6 pages, 10 pages maximum. So it's really easy to read. It's less than 100 or something like that. It's not a big book with the appendix and everything else. It's less than 100, 98 pages. So now for easy to read compared to that Bible here. You know, looking at, what is it? How many pages? Just to give you an idea how that in comparison, it's 800, like 900 pages. 900 pages compared to 100 pages. So I encourage you to go read it. Okay. I found the most interesting stuff is in the annexes at the end. So if you guys have done that, some of you, or contracted certain people to help you and your technician also put together an electrical safety program. They laid out an electrical safety program right here for you. So you grab it and you modify it and call it 3M. They have there's a bunch of very smart people specialized in safety put that document together. So that's probably one of the best, I think, there. Hazard analysis, you remember 3M hazard review record, that's almost the same thing. A little bit more details they do. They do risk estimate and risk evaluation. Risk estimate and risk evaluation. A lot of risk estimate and evaluation. You guys do it. You do this one through 3M review, hazard review. Job briefing and planning checklist. So they have a whole things before you go. Before you go work on this electronic circuits, you sit together and see what we're going to be doing, who's involved, and what's not. Plan the day, basically. Have a plan and plan the day. Every job have to have a job briefing. And the single most important thing is that you can be sued if you don't do is energized work permit. When you work on energized equipment, and there's exception. What you guys are doing here is the exception for you because you do test a lot of equipment. Really, every time I want to go measure the voltage here, 50 volt or 70 volt or 120 volt, I'm going to go write a whole big 2-page energized work permit and have 5-6 managers sign it, plus the electrician and the technician. So a lot of stuff, and day-to-day testing things are excluded. Now you go open a switch gear and start putzing around with it and adding another circuit to it, that needs an energized work permit. So these are the stuff that we're going to be doing. Any comments, guys? Questions? Questions? Everybody's good with that? Okay, I didn't put you to sleep yet. That's good. Electrical safety training. Like I said, it is the law. You guys, that's why 3M put you in here. It's the law to do it. The law for us is OSHA, Minnesota OSHA. And right under these federal and state regulations, it will tell you subdivision S. It will tell you guys you have to have electrical safety training, and it defines in 70D also, it tells you that you have to be a qualified person, define a qualified person for you. To work on any energized electrical system, you have to be so-called qualified person. And in the state of Minnesota, qualified, they define it. Both guys, the OSHA and the 70E, very clear, and NEC codebook. NEC, 70E, and OSHA define it very clearly. Must be trained, so you have the knowledge, the skills, and the knowledge on the construction and the operation of the equipment. And specific equipment. You have the knowledge and the skills on the construction and operation of the electric equipment, and have received safety training to recognize and avoid the hazard. Then you see this is how they define it here too. You have to have received safety training to recognize and avoid the hazard. To be qualified, I guess based on the work that you guys do, you don't have a whole lot of regulation, unlike electricians, where you have to. The electricians have a lot of regulations, 2-to-1. So if you're doing electrical work, you have to have licensed in the state of Minnesota and supervise no more than 2 unlicensed electricians right underneath you. For you, there is not, unless you have a policy, there is not a ratio where how many engineers have to be compared to how many technicians. I don't know if you guys have internal things. There is not in the state of Minnesota that I know of that says you have to have 5 engineers when you're doing in this lab versus 10 technicians, or vice versa. But for the electrical work, if you do electrical work, there is. The qualified, they use the word qualified. I'm a master electrician in the state of Minnesota, so I'm qualified by the state to do electrical work, but I'm not qualified unless to work on some of your equipment that you're doing right now, unless I have the knowledge and the training. The knowledge, the training and the knowledge is a big deal. Having a license is one thing, guys, and having the knowledge is a completely different thing. You know, I could screw up any one of your labs if I come there, unless I have the knowledge and the training, how this equipment work and operate. This is so important, knowledge and training. In the engineering community, we call it competent. You have to have the competent in what you're doing. You know, otherwise, if you don't have the competent, it doesn't matter what you have, what your degree is and what's not. And of course, receive training. If you are to do electrical work, you have to receive training to avoid and recognize the hazard. So electrical safety training. So you have to be, first you have to be, in order to work on any of these systems, you have to be a qualified person, and we talked about qualified person here. Knowledge and skills in how the system operates the equipment, and have received safety training. And qualification can be unqualified to work on this piece, but I might not be qualified to work on the other piece. You have to know how things work, which makes sense. Another thing for your electrical safety, that's part of electrical safety program. So if you're doing electrical, you have to be qualified. Right? You have the knowledge and skills of operation and operation and construction of that piece of equipment you're working on. Must be aware of, and then after that, step number 2, you have to be, if you were to work your training program, guys, or electrical safety training program, you have to include that you must be aware of the precautionary techniques, including the use. You have to be able to pick and recognize the PPE. If you are to work, when you guys did the hazard analysis for 3M and you said, I want to work, yes, I do work on energized objects or equipment, then the question number 2 is, okay, great. First, you are qualified to work on it. Yep, I'm qualified. I know how it works. I know, yeah, good. Next, do you know how to pick the proper PPE to work on it based on the arc flash and the shock hazard and the arc flash hazard? That's why you guys are here. You know what I mean? That's because we walked through that one. So the PPE, selecting your PPE, and that document that we give you guys, very simple. It gives you a few things to do. So we select the PPE and also test the equipment, insulate part of your PPE, that's the dress, and test equipment. Can you use this meter on the 480, 277, 4000 amp switchgear? I hope not. Because if you, I'm not kidding you, not all meters are created equal. Be very, very aware, and I'm sure you guys are aware of that one. I don't know if you're familiar, we go over the categories of meters. Meters are categories. There's certain categories are meant for the bench to work on electronic equipment. This is one of them. And there's other categories that are meant to work on high voltage. Where did that go? No? So others that meant to work on energized object, which Fluke and Ideal guys have them, and that's another one that you can work based on the category that you do, work on energized 480 systems. So not only just the PPE that you have to do, but also the equipment that you're going to be using is going to be different equipment. So a lot of people, if they test guys, I don't know if you buy your own tools or 3M provide the tools for you. So I mean, this one would be great for what you do in the lab, really, or something similar to that, because from a safety point of view, now with the minute that you start messing with the circuit breakers, which I don't think you guys miss in the panels, you don't open the panels, do you? When you open the panel, that's what you're going to be looking at. You know, so you don't want to go work in any electrical, when they say panel, any electrical panel or any control panel that has high voltage. So you have a piece of equipment and you guys working on the control side, and on the other side, exposed power equipment coming into when you open the enclosure. I think you guys have a lot of protection in it though. If it's exposed, so you are exposed so that you're opening a panel that has high voltage, this is what you're going to use.
What do you consider high voltage?
Well, it's really, it goes by the energy. So if you're working, typically if you're working on a 20 amp circuit, 20 amp and 120, this guy will take care of you. So 120 DC or AC, control circuits, AC or DC 120, and the circuit that's feeding it, the control circuit is 20 amp or less. This is adequate for you. And I believe, I don't know if you guys, now you go 100 amp circuit, 3-phase coming, and you're checking, verifying the voltage on the line or the load side. That's what you need to do. Does that make sense? Yeah, that's what you use? Yeah, absolutely. That will take you anywhere you want. It really is. So that's why a lot of people don't carry these. They carry one good one, and then you don't have to worry about where to use it. That's the best way to do it.
There are other food models that don't have the current plant on it that are appropriate for those.
Are you asking or?
Yeah, I'm asking.
Yeah. Yes, absolutely. If you don't want to measure the clamp on that meter, you know, there's absolutely. Okay, then we talk about insulated tools and shielding. You will never ever, guys, approach a piece of equipment when you work on the energized. And again, we'll talk about energized without, when you work energized, you work with energized object, voltage rated. Now, I don't know how you guys do it on the 120. Most of the stuff that we do, that's where you guys are coming kind of from a shock hazard, not from an arc flash hazard, from a shock hazard, meaning you grab a 120 circuit that's fed from a 20 amp circuit. That circuit will send you to the second life as fast as a 100 amp circuit. Really, shock hazard. Doesn't matter. I mean, if it's 20 amp, from an arc flash hazard, the arc flash will burn you. There's an arc flash, big ball of fire. That's the arc. From a shock hazard, shock is you, here's a hot object, grab on it, and make sure you're barefoot, and go to the, the most damp location in the basement and put your foot in it. That's the perfect shock. That will send, doesn't matter really if it's 20 amp or 100 amp, you're going up, So that's why, or down, depending where you go. So when you work energized, you have to use fully insulated energized tools. I don't know if they enforce it for you guys. These are 600 volt rated equipment. So, but from a shock hazard, it really doesn't matter because these are protecting you from shock. Remember, they just don't want to shock you. Now this one, it looks like insulated, but it's not rated for insulation. Though, if you use it, it's not like, unless you really, when it comes to a 20 amp 120 circuit, it's really the amount of energy and the amount of hazard is a little bit low, but still there though. Then the arc flash, we talked about the arc flash hazard and the suit that you have to put, and there's a bunch of them. We'll talk about these one, guys. So you have to know how to select these. And we have a procedure, guys. I have an activity for you that you have to go through to select them. Demonstrate the safety work practice that are involved in specific equipment. You guys, you're the ideal situation for so many equipments that you use. And every piece of equipment have a safety procedure for shutting it down and energizing it. And the electrical hazard might be only 1 out of 10 other hazards that you have to pay attention to. Steam coming out of you might survive, electrical shock and big ball of fire, electrical arc, but the steam burn you. Right? You could deal with a lot of hazard, hydraulic, mechanical hazard, moving things, cutting things. So keep in mind that it goes back to demonstrate the safety work practice that are involved with the specific equipment. Every equipment have its own electrical safety as well as other mechanical and other energy safety too. Okay, so now that you guys know how to select the proper PPE and the test equipment and the arc flash and you know how to deal with the equipment. Persons within the limited approach, we'll talk about the limited approach, guys, and the prohibited approach. And limited approach, and these all meant really, remember, this is meant for electricians. So I'm standing right in the front of a piece of equipment, but could be you though. You are working on a controlled part of a circuit, a PLC. You're programming a PLC. And inside the box is also 60 amp 3-phase 480 feeder coming to that piece of equipment, and you are in the same panel. So you're exposed to the same hazard from an arc flash hazard. And I know they have a lot of insulation. They insulate typically, unless they're in completely different enclosure. If they're in the same enclosure, you're exposed to the same hazard, unless that incoming circuit is in a different enclosure. And I don't know if you guys get into how much you get into the control of the equipment, but I don't know how you're going to be testing a VFD or program a PLC without going and verifying the presence of the voltage, at least the presence. Do we have voltage coming in? And testing and it's not working. Well, what if the disconnect or the circuit breaker tripped on the other end? Maybe I should go verify the power, not just the control circuit. So you will be in a lot of situations verifying at least the presence of voltage. So limited approach boundary. You are in limited approach boundary. If you are to go there, demonstrate the ability to distinguish, then you have to be able to tell that this piece of equipment is hot and this is not. So can you verify? You look at the circuit breaker, and not a circuit breaker. You look at a receptacle like this one. You know this is supposed to be the hot. This is supposed to be the neutral. This is the ground. That's supposed to be. When I say supposed to be, that's how we should wire them. But always verify, because you never know how it was wired. So verifying, can you verify that this is dead? So what I always tell the people, when you verify all of them. You never know how they wired it. I always say you verify the hot, the neutral, and the ground. They're all dead. Then that's you verify. Not just the hot. Well, I verified that the hot here, and some electrician flipped it and make the neutral hot. I get really good zap. So if you are to enter the limited approach boundary is typically defined by 3 feet by the NEC code book, and it goes all the way to 4 depending on the equipment. You enter that area around a piece of equipment, you are in limited approach boundary. So if you go there, you must know how to distinguish between energized and non-energized objects. We're going to be looking at this one, as these suits, guys, have some stuff. You're going to be verifying which one is the energized, basically. Okay, be able to determine the normal voltage level. It is, I always say, guys, it's a crime going to troubleshoot a piece of equipment and you don't know what type of voltage level do we use in the US. So you're measuring there and you find 220, 222, and you don't know that 240 is a system that we do. So you need to have an idea. For example, 28120 is a nominal voltage system that we use in the US. 480, 277, 3-phase system. These are the nominal voltage. You're looking at something closer to these voltages, 240, 120. I talked to the electrician guys when we have center tap delta. You probably don't deal with them. There's a system called center tap delta, where you can get a voltage from one location, 208, and another voltage 120. So if you don't know that this exists, you can't verify. You don't know what you're verifying. So first you need to have an understanding. When you have a piece of equipment, I don't know what the control voltage. Your control voltage can go from 12 volt, 24 volt, to 48 volt, to 120 volt, 300 volt. So you need to know what you're looking for. So this is very, very important, guys, when you before verifying what? The absence of hot for what? What voltage? What am I looking for? So it's hot, and what's the voltage you're looking for? So to do that, you have to have an understanding of what the typical voltages for you, the control voltage they're using for these equipment. Am I having a 24 volt, 26 volt, and my system is supposed to be 24, the nominal voltage, so there's fluctuation a little bit, it's always fluctuates, or am I looking for 480? So, and what do you guys use? Do you use like control circuit 24 volt, 48, 120, or all the above in the control side? 12 volt? for the equipment. Okay. So single phase or three phase? Three phase. Okay. So you have to know the voltages levels. And then of course there's a distance procedure which you, my friend, have an activity for you. You're going to be verifying how far you have to be approach distance requirement for working alive. So if this is an open piece of equipment, how far can I get before I have to basically put all these things on me? So how far? Typically 3 feet or three all the way 3 to 4 feet. And of course, choose and wear, not just choose and wear the PPE based on the job hazard analysis. When you analyze the job, most of the equipment that you guys are working on, the control panel will have a label on it that says PPE category 0 or 1 or 2. You are, when you open that panel, you are to follow the procedures category 0 through category 4. And with it comes a dress of gear that you have to deal with. So, any comments, guys? Questions about that? So that's, and then voltage testing. When we deal, now we know how to do it. You have to test voltages, like we talked about the meters that you have to do. Select an appropriate voltage detector and demonstrate how to use the devices to verify the absence of voltages. You cannot believe, guys, we're recording now. I can't say things that I shouldn't, but you know, people have burned their hands using the wrong meter on the high voltage side, because the meters these can literally explode in your hands for a fault of not your fault. It's not your fault. I mean, they're not rated to handle the short circuit or the transient that piece of equipment can create. So you could use it properly and end up burning your hands or your face, because they are not rated to handle the transient, which you guys have a lot of because you're mechanical. There's a lot of VFDs going up and down transient in the system that can shoot the voltage up to 2000 volts, bring it back. You know, the transient that goes in your system that could go right here and short this one and make it ball of fire in your hand. So that's what you're going to be rating of the equipment in a second. Understand the limitation of each specific voltage detector that might be used. And you guys use the top one, category 3, typically 4. 3 and 4, these are the ones they're going to be using, either category 3 or 4. 1 and 2, you don't want to use them. 3 or 4, that's what you're looking for. This one, for example, and the go by, in your case, this one that I'm holding in my hand here, it's category 4, 600 volt, up to 600 volt category 4. But if you are to use it on 1000 volt, which you guys don't, 1000 volt, it goes to category 3. So up to 600 volt, this one, category 4. So great, best protection I can get. Meaning it can handle the transient and the short circuit. So, okay, any comments, guys? Any questions? Comments, questions? Before we move on, I know in 5 minutes I'm going to give you a break, so you hold your horses. Hold your horses. Retraining requirement. You guys are supposed to get retrained. You do the training once every 3 years. I don't know if you know managers. If you're a manager, you probably know that by now, because in 2012 they changed a few things here. You are supposed to do this training, being tortured by Chad, every 3 years. At least every 3 years. Okay. No, this is better than being tortured by Chad every 2 years, like the state of Minnesota requires 16 hours to be a master. So every 3 years, or the following. Did you guys hear me? Every 3 years or the following. Here's the following. An employee is not combining with safety work practices. So if they notice that you're not adhering to the rules and regulation for safety, then they send you to training again. So your supervisor have the power based on 70E, and I'm sure based on also the rules of 3M. If they watch you not following the procedure, he has the power as well as the authority to send you back to training. So employer is required to determine the compliance through supervision and annual inspection. So that was in 70E, and that's a law. Remember, that is the law, because somebody get hurt under your watch and they haven't been trained every 3 years, or if others can verify that they were sloppy, they don't know how, they were trained but they don't know how to use it, you're supposed to retrain them. Am I making sense? So if you're not compliant, you have your supervisor by observation or annual inspection can verify, send you back to be tortured by Chad. Instead of every 3 years, every 1 year or 6 months. New technologies. Now you are the top technology here. The new technology, new machine you brought and you're installing it, have no idea how the safety, you need a safety training related to that piece of equipment. Electrical safety training. So safety practices were not in a normal work scope, scope of work. So if you have a task that's really required, you don't do it a lot, you do it once a year. So that you forgot the safety training associated with that task, you are supposed to get training on that task. So tasks that are performed less than once a year, require a retraining performance. So once a year is good. Less than once a year, every say 2 years you do that task, then you have to be retrained on the safety associated with it. Okay, and if all hell break loose and you are the best, like most of the time, guys, then you have to hire us every 3 years to come and torture you. Does that make sense? The training, but typically every 3 years, or if any of the above are mentioned. Should we have 5 minutes? This is a good breaking time. And can you guys please respect the 5 minutes so we can keep moving? I have a lot of stuff that I need to do. So just stretch around, go to the bathroom. Yes, just 5. All right. So 5 minutes.
Who does the, who comes up and says what PPE level you need on your machinery?
Electrical engineers. We will go over that one. They have softwares that we call short circuit analysis softwares and arc flash analysis softwares. And they take the risers in your buildings here, and they can take it all the way down to typically to the panel, but they can take it down in the building. So typically either for the building they do engineering or the electrical contractor. For the equipment, it goes into the shoulders of the manufacturer.
A lot of times, especially when you're coming out, you have label that will say your class.
Yep.
I said you were class. In the older stuff, because usually it's based on the circuit is connected to the building it's in, and then based on what that has, based on what's in the next panel. So someone has to go through and do all those calculations for all of these areas. So usually, like in PNCS, we'll have like the process electrical person will go through. And when we put in new equipment, we calculate all of that and label the, now not everything, because we have older equipment, and not everything, either it's not labeled, it's calculated somewhere, and it's not labeled, then it should be on your.
Okay, so let's a little bit talk about, guys, about release training. Workers who are likely to be exposed to live power must be trained on. Only the people who have to be exposed to live powers, which you guys see in the surveys, looks like all of you, that you are working on exposed to more than 50 volts. So you have to be retrained on the following. Let me grab my my equipment here, my pointer. So if you work on train on the following, to release victims from a circuit. So we'll talk a few things as how if somebody is being electrocuted, and would you sit there and watch him turn into a hot dog, or would you, what would you do? You know, de-energize. The first thing you need to do, look around. Where is the closest disconnect switch so you can slam that thing, or the closest emergency shutdown button? That's part of the training that they do for new equipment. When you guys buy new equipment, the first thing, where's the emergency button so you can shut it down and save the rest of his hand or whatever, for whatever reason. So that releasing the victim, de-energize the circuit if possible. So how do you remove the individual from the circuit? And that's different from one equipment to another equipment, right? So how do you de-energize the circuit? So when you're working, part of the debriefing that they use, and a lot of it related to opening panels, but it's also to you guys. You open a control panel, you're going to work on it. You have to debrief and stand and talk to each other, you and the team who are working on it, before you start. Part of that debriefing is what happened. How can we shut the power if somebody got electrocuted? Where is the closest disconnect or emergency button that we have to shut down if somebody got electrocuted. That's so you identify it. So I'm working on here, and if you're working on that one, here's the closest that I can shut that circuit. You got electrocuted there, you know, I can turn it off right here. So you have to identify that one. Do not make contacts. Of course, we all guys learned this one in grade school. Is if somebody's being electrocuted and shaking and dancing, don't go dance with them, because you become part of the circuit. And remember, to get the perfect shock, you have to be barefoot in a concrete, wet, or preferably full of water on it. That's a perfect shock. Or you grab a pipe, an EMT conduit. What happened, guys, in the summer like us, you know, t-shirts, and I'm standing right here. You know, this could be grounded. I'm holding, my hand is here, sitting like this, and I'm working on a heart. So look, it goes right through my heart. Don't ground yourself. Make sure when you work with you learned this one a long time ago, you work with one hand. Don't put your other hand on, especially anything grounded when you work on anything hot. You do not want to ground any part of your body where you're working on energized objects. So use an insulated object such as a hot stick. Insulating objects, hot sticks, or we always, you know, if you're in a construction, somebody got electrocuted and you want to remove them, look for the closest non-wet wood piece of equipment. So you can slowly, don't bang them on their head, just slowly push them away. If you can't find how to shut down that piece of equipment, which you should, if you have debriefing before you start the work, see how when you do the debriefing, you identify how to shut down the system. But if you didn't, and nobody told you, and the guy's sitting on a circuit of 120 and shaking, or 240, the closest wood piece of equipment, slowly push him away. What emergency procedures are to be followed? First, you have to, of course, in your case, guys, this is your 911 call, right? You're familiar with that one. And know the location of I don't know how to use that one. AED, do they train you how to use these? The problem is, yeah, know how to look, is that where they revive your heart? So know the location of one of them, but I don't know how many of us have. Do you guys not safety training, what do they call it? First responder training. Do you do first responder training? We used to do it, not through work, through others, yeah. So that's the problem, is if you know the location, you don't know how to use it, it doesn't mean much. But at least if you know how to use it, revive them, bring them back until the emergency people show up. So that's if you work on energized objects. You have to have some of these training. Any comments, guys, questions? Release training, how to de-energize. So really, when you fill the energized training permit, all these guys are listed on it. How do you shut down the system? How do you sit and you discuss it, you debrief it with the group, so everybody's aware if something happened, what to do, you know, other than just dialing 911. Or in your case, 234. Documentation. Because 3M, your employer, guys, shall have a documentation that each employee like yourself have received the required training, and that's why we take that quiz at the end, guys, end of the course quiz, that you have received it and you know what the training is all about. And they keep it on record. This is just FYI, a record. The training topic, we have to tell them what the training topic. You guys have documentation of the training topic. Employee name is on it, on the quiz, and the date of the training, and will be kept for the duration of the employment and skill verification annually. So the reason why people do it, and we do it done with you too, guys, if something is to happen and OSHA walks in and say, okay, show me your safety training for your employees, and you don't have this on record, then you're violating the OSHA safety training. So you could be liable, your company could be liable. And they're trying to make right now, with if you look at the work permit that you guys are doing, and 70E has, you know how many signature? Well, you know why they put the engineer's signature, the electrician's signature, everybody who is responsible signature. Because when we kill an apprentice in that switch gear, and they go and look at your signature, everybody sign on it will be liable if there is a mistake. You know, so they make it really, really hard, especially for working energy. It's really hard. And I'm talking about the high voltage, guys. We, what is it, maybe 7 years ago now, we had an electrician got killed in downtown Minneapolis. One of our students at Dunwoody, first year apprentice, working on a switchgear for 3,000 amp for, I think it was People's Electric. And they were working energized, no PPE, 3,000 amp. 3,000 amp for 8377 switchgear. Stick your hand there, not energized, and tying a new circuit to it. And somehow got an arc flash, something got dropped into that switchgear. Big ball of fire came, engulfed him. No, nothing. He's just like Chad, standing right here. So engulfed him and killed him. So it's no joke if you're dealing with big stuff. For you guys would be the feed to the electrical equipment. Take it very serious, especially the line side of the equipment. It's, if you have 3-phase, it's no joke. The arc flash or the electrocution hazard. So the electrical hazard is defined as the threshold is 50 volt based on the resistance for the human body. So it's kind of if it's more than 50 or less, it's considered safe from a human point of view. Not from an explosion point of view. You could have a 50 volt, guys, if you're using hazardous material. You could have a little arc coming out of a battery, a 24 volt battery or 12 volt battery that can ignite the whole building from a fire point of view, right? Is if you have flammable material in your area. So, but from a shock point of view, an arc flash point of view, 50 or less considered safe. Hazardous current. Contact of the body with energized parts. From a shock point of view, and from an arc flash point of view, 50 less than 50 is considered 50 or less is considered safe. More than 50 is considered hazardous from a shock point of view. If you have more than 50, guys, low current, muscular. So if you have low current, high current burns. So these are the effects on your body. Incidental injuries like falls. So what happens if you get electrocuted or electrical? What type of hazard you can get from electrical? You can turn into a hot dog. We all know that. That's if you get 480 right across this hand and this hand. That's guaranteed. That's the easier now. By the way, a lot of us are smart enough not to get electrocuted. A lot of us, it really is. But what the industry for the last, my God, 10 years have been going is the arc flash. A lot of us not smart that if you open a panel to verify the line side of the switch gear and you drop something inside the panel and you don't do anything, or it could be a short circuit happen inside the panel while you are in it, or guess what happened to? Say you have a storm, and there are stories, guys, that electricians were working on a panel, right? And there were a storm, and we get a lot of storms in Minnesota. What do the storms do? They hit lightning, hit the transmission line. What happened when lightning hit transmission line? That big pulse of voltage goes right through the transmission line down into your facility. If you're in close proximity and you have transient and you have the whole thing, it could go all the way down to that panel. At that time, there were electricians working the panel. When there was a storm, the transient came and they were using voltage, voltmeters to verify the absence of voltage that's not rated. So long story short, because of the higher voltages transient, it shorted right through his meter. You panicked, so you dropped the meter into the panel, right? What happened? Now you aggravate the situation, big ball of fire. I think 3 people died from that incident, but it was a big piece of equipment. So that's what happened with the. So you could be in a panel not doing anything, and a transit coming from a lightning or from switching. You guys have a lot of welding, probably in certain areas, welders turning on and off, putting transit to the system. But you can solve most of these transient problems by having the proper tools. Of course, you can survive being shocked, but you can fall off the ladder and break your neck. So that's another thing. So, or create a fire in the area. Exposure to the arc. So these are the shock that you can do. Low current from high current, from burns into stopping your heart, into other things. And like I said, a lot of us know that one, but now the buzz is the arc flash. Arc flash is a fancy name for a big ball of fire chasing you. That's always in plain English. Big ball of fire chasing you. You guys, we all have ball of fires. When you short, go to the 120 and short it and look at it. 120, and you'll have a little ball of fire. You know, maybe a 1/4 of an inch diameter. But think of that one, make it 3 foot diameter. That's your arc flash with a lot of energy in it. So what happened? Surface burns. You get burned, blast, pushed against the wall. Here, break your back. Hearing and vision. You damage your hearing, damage your eyes, and of course it goes right through you, and it damages your respiratory impairment, so it damages your inside. So it's a bad situation, and we'll look at that one, guys, later on in a second here. Electrical shock. When I start working with electricity, guys, it confused me, especially the arc flash. There are two unique, separate, different hazards in every electrical circuit, and they're unique and separate. One of them is called the electrocution, and the electrocution is very simple. If you work with the right equipment, like here, rubber gloves and right equipment, and you don't touch anything energized, you will not get electrocuted. That's called the electrocution, electrical shock. That's unique number one. Unique number two is the arc blast, arc flash, arc blast. That's a ball of fire chasing you. Now, it doesn't matter if you're carrying a fully insulated plier like this one and you have a big ball of fire chasing you. It wouldn't do you any good, would it? Nothing. You're engulfed in a big ball of fire. So these are unique, completely different, completely different. So you could be standing in front of a panel, not touching anything, not doing anything, and the panel is open and you are within the limited approach, or the arc flash boundary. They call it arc flash boundary, 4 feet, unless you calculate. And some transient happen in the panel, and the panel explodes, and you could die. And all your insulated tools doesn't do you any good. So I always like to explain that one very clear. Shock hazard is completely, not completely, it's separate, completely separate almost than the arc flash, arc blast hazard, that big ball of fire. The amount of current. Now, if you have a shock hazard, now that's your shock hazard. The amount of current, the frequency, and the path, and the body mass. This is one of the locations where if you have a fat and fluffy, you have more chances of surviving than if you're skinny. An advantage. Finally, there's an advantage for for having some weight on you. Finally. The duration of the current, how long, and the phase of the cardiac cycle. So when you have a current, obviously, if you have 10 amps going right through you, it always takes is less than half an amp to kill a human being at the right voltage at 120, guys. You don't need 1,000 amp to kill him. The right shock from right hand to the left hand between two. Here's the hot, here's the neutral, and half an amp at 120 going right through your heart. You join the Lord. So so that amount of amps, the higher the amps, the more you will burn. Obviously, the frequency has an effect also on your heart. The path of is it going right from right hand to the left hand through the heart, or is it going from between two fingers, right? Or is it going from a hand to the leg so you can survive more? And how do you decide, guys? If here's energized and am I insulated here? Yep. Then where am I going to put my hand? Here, going right to my heart. Or am I barefoot on concrete, wet concrete that day? Yep. So it's going to go from here right through my heart or through my legs all the way down. So that's the path. The duration, is it going to sit there for 2 hours? You're done. 2 hours is too much. Or is it? Or somebody's going to find you within less than we say a minute and push you away. And so the duration and the phase cycle has to do with also with your rhythm of your heart. So mostly, guys, the voltage. The higher the voltage, I always say, guys, higher voltage. Lower voltage will kill you, but higher voltage will basically torture. Higher voltage, low current typically torture, but higher voltage, high current will burn you basically. So here's a few things, guys, about a couple of threshold. I think your friend Chad is going to be in this category here, if not higher. Some of you guys, how many of you in this category? 115? No, somebody here? 115? I mean, my God, even I don't think you're 115. My wife weighs more than that. But so most of us are right here. So you can see what happened, guys. Perception of threshold at the 60 hertz is 1.1, and remember, this is milliamps. Painful shock. Look how long. I mean, all it takes, and see, this is just at 120 volt. This is typically at 120 volt or higher. You know, the higher the voltage, the more lethal. So And then we have let go threshold. So now you freeze your muscles, and the problem is when you freeze your muscle, you can't let go. Now you sit there being cooked. Like 16 milliamps, I remind you, milliamps. And breathing affected, blah, blah, blah. So you can see all these. And then for 3 seconds, you can send you to the second life. You will stop your heart here. So these are a few things, guys, that you can see. It doesn't take much to really freeze you in place. Look at that, 16 milliamps, or what it takes to freeze your muscles, and cannot let go in a circuit, on a say 120 or 240 circuit. So that's why your GFCI trip at 5 to 6 milliamps, right? 5 to 6 milliamps, that's enough to let go, you know. But you go higher than that, it will burn you. And there's also surges, high voltage surges with the joules over here and the time and what's not. But these are a few things that can get you. I'm sorry, some of these are graphic. I shouldn't probably have did that. So when you have a shock, you have I squared R. You guys are familiar with I squared R. That's how much energy goes through you. You don't have to look at it. I apologize. So that's the heat. That's the heat. Current flows, current all typically nerves and at least resistive typical. Okay, so we have the nerves, damage the nerves in the vessel in the vessels. Internal and external damage. Internal damage can happen to you guys because the current goes right underneath you. So your skin could look good, but internally you're burned. So and significant internal damage and tissue death, even though the external could no and little external evidence. So be aware of that one. The point of entering the current and the point of exit the current typically is where it's very obvious when you see shocks. So obviously that's what you're trying to achieve. For you guys, I mean, if you're working on the 20 amp, I mean, unless you really grab that thing in one hand and the neutral in the other hand like this, and you sit there, or you grab one hand here and barefoot in the basement with water in it in one hand, you probably would never see something like this. That happened in the higher voltages. So I'm away now. You can come back. Okay, effect of electrical. So that's the electrocution. The electrocution, guys, burn your muscles internally, stop your heart. The point of exit and inlet will be completely burned, and so bad news. Now that's what a lot of us are smart not to use. And how do we avoid what you guys have seen? By always using the right tools. The gloves, you have rubber gloves, and we protect the rubber gloves with another gloves right at the top of it, one to insulate and one to protect the insulation, and always work with insulated tools. So instead of your finger, we're grabbing right here, and your finger now if that was not insulated and you're doing it this way, now you got into contact. The current will go right through you. So insulated tools and insulated gloves will protect you from the shock hazard. Insulated tools and gloves. And of course, gears, eyes, and what's not. Now the arc flash. Now the effective arc, remember, they're two unique different hazards. One shock, which we know how to avoid. Don't touch anything energized. That's what the shock is. And the second one is big explosion in the panel for a fault of not yours, not your fault. So this is the passage of a current between. So look how they define it, guys. The passage of a current between two electrodes through a conductive ionized gas. If you ever seen, if you put the higher the volt, if you put you have high voltage here, guys, and ground here, and the closer you get them together, the more they ionize the air. And you'll see an arc coming out of. If you try it, the closer. So that's why when they design the equipment, they design them with a minimum clearances between the phases and the neutral. The higher voltage, the more clearances they have. The lower voltage, less clearances. Because at one point you ionize the air, and the air becomes conductive. And that's basically the essence of an arc flash. Arc flash, a short circuit is when you grab a hot and a neutral, put them together like this, and preferably you bolt them. If you have bolt them, that's a short circuit. An arc flash, if you accidentally drop, say, a screwdriver that's not insulated like this, drop it and it leans on the phase A and the enclosure, leaning on, bringing high, they call it high impedance. That high impedance, believe it or not, is destructive. It creates a big ball of fire. Um, or like a transient, you have a high voltage. This distance is for 480, right, or 120. Now, what happens if you have a transient in your system? The transient goes, if this is 480, it could go as high as 4,000 amps for a very short amount of time. For 4,000 amps for a short amount of time, these will arc. A big arc jump in here, and the arc will escalate, and a big ball of fire come out of that. That's your arc flash. So what's your job then is to be ready for it. Yes, sir.
So what kind of flashes is it? The backhoe rips 1.5 kilovolt line up?
1.5 kilovolt.
3 kilovolts. Short. It was a big ball of fire, but it was
Yeah. Well, you will.
short.
Yeah. Well, it's not a short circuit. A proper short circuit is bolted. A bolted short circuit, you touch them. Anything that has an impedance on it will create an arc flash. So, and you will create an arc flash. You will see a big ball of fire coming out of it. So, arc flashes, the electrical equipment can be caused by a couple of things. Look at this. Short circuit between two conductors or a conductor and a ground. That's exactly what you didn't describe it, but somebody ground it, right? Cut right through it. This is where a lot of people don't understand. Flash over due to surges, corona, or contamination of insulation. Now you get into a switch gear that's not insulated, and over time, if you don't do proper maintenance on these switch gear, guys, 5-year or 3-year cycle maintenance where they shut them down, go clean them, retorque them. If you don't do that, you have enough contamination on them that created a path between a hot and a ground or a hot and a hot. And at one time, you might open the panel, and at that moment, they arc. And it escalates into a big ball of fire. So this is not a fault of your own. You're not doing anything here. Short, typically, a lot of people will drop accidentally a little piece of equipment right in the panel. That's where you get a big ball of fire coming out of it. You're short to ground, typically to ground. So, but that's that flash over due to surges or coronas. That's typically you have no control over this. Mechanical failure of equipment, like a switch blade, you work it and it fails mechanically. Short the ground, for some equipment in high voltage, when they open the switch, they ground. So the switch go from this side, which is energized, to this side, which is grounded. So if one of them went to the grounded and the other one sat on the energized, what did you get? A ground fault. So metallic tools in contact with energized objects, you dropped it. Body parts in contact with energized parts. So these, even if you have an electrocution, your body can create also a ball of fire. You're creating a high impedance. So these are the things that happen. Big ball of fire can chase you. Any comments, guys, about arc flash versus shock hazard? Arc and shock. I'm always scared if I open a panel. You go to 120 here, guys. I mean, arc flash, non-existence. But the minute that you open a panel, shock is still there, though. You could die. There are people died from a 277 there. Got shocked. Shocked completely. Shock is anything higher than 50 volts, you could be shocked and killed. Remember, arc flash, typically, if you're not in the panel, or if you are not in a control panel that have 3-phase, or too many amps, like 50 amps, 240, 3-phase or single phase. If you're not in this situation, arc flash is almost negligible. Almost negligible. Yes, sir.
Yeah, so I think what you saying 120, I mean, 120 here because of the 20 breaker on it, but I mean, if you had 120 with a fair amount of current, good conductor, with keeping that arc flash, you're going to get a pretty big flash.
Yeah.
If it's able to source the current, because the current is causes the flash, not
Yeah. With you, when we do you do SKM? Do you use SKM? Like, yeah, SKM is software that we use. And I can guarantee you, because I use it a lot, if you go to the level of 28120 panels, it becomes category 0, basically, which is a 2000 amp.
Yeah.
Oh, now you get into a 2000. Yeah.
I'm just
Yeah,
I hear a lot of talking about the voltage, but
yeah.
it's the current that is.
Yes, 2000 amp. Now you would never get a one. Yeah, what I'm thinking of you guys. Yeah, what I'm thinking of you is a control circuit with a 20 amp circuit to it. That's what I'm thinking of.
That's what I, yeah, I
Yeah,
want to make that distinction.
yeah. But if you have a panel, 2.8 panel, and a power coming to it at the level of 2.8, 120, obviously if you have more amps, it will be bigger. So, but and the worst of the worst is if you have 480. If you have 480, always think arc flash. 480 is don't open any panel without putting your gear into a 480. Um, uh, so that's equipment. Here's an arc flash, guys. We said something, it's not bolted. You drop something, it's high impedance. We call it a little bit high impedance, short between a ground and a hot or a hot and a hot. So what's wrong with that one? Look at the amount of heat there. Now you got yourself into a furnace. That could burn you, right? Easily. And how about copper expanding at this amount? That will bullets chasing you. And if that's not enough, here's your bullets chasing. If that's not enough, we have a pressure. So if you survive a bunch of bullets here, and again, we're really talking about 480 here, big stuff. I'm scaring you guys here. I sound like insurance companies when they want to sell insurance. Do I sound like this? So the pressure can push you off the ladder. Now he broke your neck. And if that's not enough for you, the sound wave can deafen you so you can't hear. And a lot of people can do that. Again, here's the bullets too. And intense light, and now you can't hear, you can't see, and they're pushing you and shooting bullets at you. What worse than that? That could happen. And you're being cooked too with intense heat. That's what an arc flash is. And that's why it kills guys on the 480. Like I said, 20 amp, 120 in an isolated area. You're very limited. Don't take it lightly though, but it's limited. But you open any panel with a three-phase or higher voltage in it and higher amps, be very careful of these. Any comments, guys? Questions? Comments? Going good?
I guess the other
Yeah.
thing is to point out the copper vapor. That's why the face shield report, because what's the first thing that happens if you do exactly. And so,
Inhale
let's
it.
say a lot of the burns you get will be your lungs because of that vapor, and that's why with a lot of those you have face shields to
Block it. Yep, absolutely. To block it, you go higher than category 0, you're looking at face shield to protect you. So it's a bad situation. That's why, guys, OSHA and the rule, I want to remind you, the rule is de-energize. And especially if you're working on power, the rule is de-energize, if you can. Again,
Is that outfit, fire resistant here too?
this one? Yes. Yeah, arc resistance, they call them now. They changed arc resistance. After in 2011, they went from fire resistant gear into arc resistance because arc more encompassed the fire and the arc.
So the student wasn't wearing one of those?
If you're working on certain categories, you have to. We'll talk about when do you need this. No, he was not wearing anything. He was not wearing anything. Yeah. We had just a guy at the Mall of America. I don't know what happened. OSHA was investigating. I don't know if you guys heard about it. One of our students, same thing. The maintenance guy told him over Sunday, on Sunday, Sunday afternoon, to go thermal image the panel. So you open the panel and you just point that thermal gun at it to get the temperature of the logs. So the kid is not licensed to work there. He's not supervised. You have to be supervised. If you're not licensed, you have to be supervised. On a Sunday afternoon, non-supervised. So when you open the panel, these big panels, accidentally something dropped, little pieces of connector or something, dropped into a panel, big ball of fire come out of it. He told me he saw his skin melting. And nobody was there to help him too. The problem is he was in a room, electric room, nobody was there. So we have to crawl outside, and he has a go-kart. He found a go-kart, and he said he was riding the go-kart at the Mall of America as fast as he can do it, and he can see his skin is melting at him until somebody found him. He survived though, but with second degree and first degree burn all over his body. So that's how bad and he said, oh, what happened is something happened in the panel and it exploded, and nobody was there to help him too. That's where the teams, when you work on 480, you work on teams. So if something happens, somebody's there to take you. you know. So don't take, especially the younger ones, don't take this serious. I mean, I tell the students at Dunwoody, if your boss tell you to do something, you have the right to refuse. It's your life on the line, you know. If it's dangerous, of course. Not not anything. No, if it's dangerous. If it's dangerous. Not say go do your work and you say no, I don't want to do it. Cause of burns due to arc. Here's a few things, guys, we can do. Incident energy on exposed flesh, you're done. That's why we dress you up. Molten metal on exposed flesh, also you're done. How about your clothing ignited? That's why they have the arc rated gear that you put on you so you don't catch fire yourself. Clothing melting onto the flesh, that's why you get your nylon or anything that can melt and on that one. Heat penetrating clothing, that's why we have all these gears that they have arc rated clothes that you put on that first it doesn't ignite as fast, it doesn't penetrate through, and it doesn't melt into your skin. Does that make sense? Under certain circumstances, guys, if you're in category 4, they want you to wear an underwear that cannot ignite when you work on that. I'm not kidding you. An underwear and a t-shirt, it goes down deeper. So it's not just what you wear underneath it. You have to wear layers and underwear that doesn't ignite, category 4. So not just what you put on yourself. So, all right, you might have to turn your face. Yeah. Okay. External burns, arc flash when clothing. This is clothing ignites. Look what happened. You burn your part of your body too. Here's an advantage. You can come back. Here's an advantage of being old and smart versus being young and smart too. But these are survivability, percentage of survivability from statistically. So the older, look at that. Some of you guys are in this category. I think some of us are here and some of us are here, right? Age group. So look at that. The older that we are, the less likelihood that we recover from a burn. That makes sense, right? So this is the survivability. So for example, if you are 29, look at this. If you are 29, look at this category, or if you are 59. Your chances of surviving if you're 29, body burn 75%. The survivability, if you have 75% body burn right here. If you are young buck, you have 60% chances of surviving. If you're an old man like Chad, is it like 25 or something somewhere? So obviously the older we get, less we can survive for a lot of other things. So this, but we're wiser though not to do a lot of things. So this will tell you if you're younger, you have chance of surviving a burn, a level of burn. Other effect of the arc flash, we told you guys about the expansion of the copper. Air shock, look at this. How can you handle something like 300 mile per hour pushing you? Material up to 300 mile per hour. That's, how about, look at this one. How about a sound to 160 dB? Now these are gone. Now you have to go fix them. Can produce hundreds of particles, average workers, hundreds of pounds of force. So, and it pushes you guys. And we'll talk about why they don't have a category more than category 4 right now. They have 0 through 4 because the categories, guys, are meant to protect you from arc flash, The blast, that big push, they discover the smarter than Chad when they do their experiments. After category 4, you will survive the arc, but you cannot survive that push. it will kill you. So it's no. I mean, you will survive the fire. You're not going to die out of fire and the arc flash, but the energy pushing you, the wave that's going to push you off of your feet and throw you against the wall will kill you if you go higher than category 4 level. So you can look at that, enough to lift a worker off their feet and into the equipment. So that's why after category 4, just don't bother. When we do, don't bother to work on the energizers. I did short circuit analysis with the SKM for us at Dunwoody, and we have a piece of equipment, 3000 amp 480, coming to feed the building. I don't know if you're familiar with the concept called 6 disconnect rules. They allow you 6 disconnects without a main. So if you see them when you come into a building, they will have 1, 2, 3, 4, 5, 6, no main into it. If you work on that piece of equipment which has no main, terminating, energize, or torquing, or whatever, I did the analysis. It was, there were something like 120. The calories were 120 per centimeter. So, and 40 per centimeter is the max. Category 4 is 40 calories per centimeter. 40 to 120. So it tells you immediately, the software says, this piece of equipment shall not be worked on energized. So what do? Contact Excel, let them shut down and work, lock it, tag it, do the procedures, then work on it. So not all the, and you guys don't have to worry too much about this one. In your level, you wouldn't encounter that one. Create electrically, okay. Hazard mitigation. So what do you do when you know all this stuff? Step number 1, guys, is create, what they call it, create an electrically, I like the term that they use, electrically safe work condition. Work condition, de-energize and lockout. It's a fancy name for de-energizing the piece of equipment. You go to the stop button of the machine, shut it down, you walk into the disconnect, turn it off, lock it, tag it, and there's a couple of procedures. Then you go verify the absence of voltage. After you lock it, tag it, then you go push the start. You guys are supposed to do this one. You go push the start. After, does the machine start? No. Then you have to grab your meter, the good one, and go measure the voltage on the line side of that disconnect, on the load side of the disconnect, and the controller. No voltage, face to face, face to face, face to face, face to ground, face to ground, to ground, done. Now the piece of equipment is safe to work on. So that's the lockout, tagout procedures and de-energizing. And if must remain energized, use, if you, again, you can't emphasize the word, if you have to work energized, you have to follow the procedures and put the PPE. So we talked about that one, if, which is the exception. Number 1, you have to do energized work permit. You guys don't have to do it because part of the stuff that you do doesn't have a lot of energy in it. And I don't know, I'm saying I expect that you don't have to do it. I don't know how you guys do it when you work on testing a piece of equipment. Because you do a lot of testing. Every time you're going to go test something on the right, a piece of equipment, especially when the energy is very low. So energized work permit, but I believe you have to fill the stuff that you guys have online, the hazard review. Insulate, you have to, first, after you verify the energized work permit, basically, yours, guys, you have hazard review record that you fill, but they have 4 or 5 managers have to sign it, and you justify why you have to work on the energized, because I can't test that piece of equipment if it's de-energized. Can you? Some equipment you can't. You can't just measure the voltage and troubleshoot it. And then make sure you're going to be using insulated tools, clothes, and accessories protecting against the hazard of voltage. Thermal protective clothing to protect against arc flash. So then you have to suit up for the appropriate arc flash. You're going to put yourself in the suit up against appropriate arc flash. Any comments, guys? Any questions? So the rule is de-energize through the lockout, tagout procedure. And the exception, if you have to work on the energized, then you have to make sure that you have energized work permit. Justify why you have to work on the energized. That's what energized work permit. And you have to have the insulated tools when you work on it. And you have to have the insulated, also the rubber gloves and insulated tools that you work on it, depending on what the category. And thermal protection. The thermal protection is these guys and these things. These are, depending on what the category that you do, is your thermal protection. To protect you from that big ball of fire. Any comments, guys? Any questions? Comments, questions? I have to keep moving, otherwise I'm looking at the clock here. So energized work prohibited. We talked about this one, guys. These guys are smarter than Chad, which is the law of the land. Selection and use of voltages, live parts to which employee may be exposed shall be de-energized. So this is where, if your employer is to ask you, and I hate to say that one, to work on it, these are your justification. These 2 articles at the top will tell you these 2, NFPA and OSHA will tell me, and if I work on things energized, they have to be de-energized. Unless, this is where the exception, remember the exception, unless, and that's on the quiz, give you a hint for the quiz. These are the exception. The employer can, your employer, through the hazard, what do you call the hazard analysis record that you guys do for 3M, can demonstrate that de-energization introduces or increase the hazard. So if you de-energize while you're cooking the chemicals that you guys do right here, de-energize the piece of equipment, that will going to create more chemical reaction that could burn the building. So that's justification for working on energize. Or Chad Curdy's heart is open in a hospital. You guys don't have a hospital here. And we'll continue operating his heart, right? These are the justification. Justification doesn't mean I don't feel, I'm lazy to go shut it down. That's not a justification. So increased hazard, or this is where you guys lie in this group, or infeasible due to the equipment design and operational limits. Troubleshooting the equipment and design. You can't troubleshoot. That's where your outlet for working on it. Infeasible due to equipment design or operating limits. So that's your justification in working with the equipment energize in your case. I assume, right? Because you might not be able to troubleshoot it, energize, But if you are, I don't know if you guys change a motherboard to another motherboard or what's not, but now you don't get into changing motherboards. Now that's your shutdown. You don't have to. When you troubleshoot it, you have to turn it on. Any comments, guys, about these? So these are the law at the top where it tells you have to de-energize. And these are the exception through the law that gets you to work on energized objects. Okay, here's an example for you where you can use the exception. Increased hazards. Look at this. Interruption of life support. Anything related to life safety, life support circuits, you can work on the energized. Deactivation of emergency alarm system. That's also have to do with life support. Shutdown of hazardous location. Ventilation system. You guys do a lot of hazardous stuff, venting. They're working in some chemicals and venting there. If it's to stop, you expose the workers into a hazard. That could be classified as shut of hazardous location ventilation. Or shutting down the whole lighting system, removal of illumination from an area. That will expose the people to a hazard. So you can work on it energized. That's for the increase the hazard. I believe you guys are here, and I'm just guessing here. Infeasibility, voltage testing, troubleshooting, and continuous process. Isn't that what you guys are? Continuous process, troubleshooting, or voltage testing. But continuous process, voltage testing and troubleshooting, if it can, these are really the main troubleshooting. If you can't troubleshoot the piece of equipment, which is when it's de-energized, I don't know how, you should. So, but what my understanding, continuous process, the process here, if you shut it down, you will create more hazard. But so examples of infeasibility. Any comments, guys, about these examples? So productivity, shutting down because I want to continue making money is not an exception. Continuous process here is continuous process because of, you interrupt that process, you create other issues. But so any comments, guys? Any questions? Comments, questions? Or if you want to, you shut that down, it will affect the whole system. That's part of your troubleshooting system. So you can see when 70E, guys, 2012 came, they make working energized. They want to limit the amount of working energized. You really want to make it to the minimum, put it to the minimum. A couple of statistics. Don't ask me to. Anybody knows what that stands for? You probably, guys. NIOSA, statistically speaking. If you have establishing a safe working condition, here's you establishing a safe working condition. Lockout, tagout procedures. And then you energize. That's a rule. 82% of the fatalities, people were working on energized. Look at that, energized intentionally. 82% of the people who died work electrical. They're working intentionally energized objects. 11% of the resulted from failure to lock out, tag out the power source. So they did not lock out, tag out power source. So the whole idea, guys, of locking, tagging as it saves lives, guaranteed. It's guaranteed to save life. Okay, so rule the energize, put the equipment in a safely working condition, work condition. To do that, there's a process that you guys do. Number one is review established 3M procedures for that piece of equipment. I assume you guys familiar with that one. Procedures for that piece of equipment. Um, but the 70E goes through the following. So if I have a machine, I want to shut it down. The first thing is you have to go and turn the machine off. How do you turn the machine off? Do you go to the disconnect and trip it, or do you go to the stop and you push the button? You push the stop button, stop the machine, turn the machine down, shut it down with the proper way through the contactor or the controller. Shut the machine down, and that's where review established 3M procedures. You guys have a lot of stuff there for this. To shut this machine, you have to do the following: 1, 2, 3, 5. Because there are other energies coming, other sources of energy. You might have to shut down a bunch of other things. Shut it down. After you properly shut, electrically speaking, properly shut it by pushing the stop button, the machine is down now. Number 2, disconnect all sources of energy. Electrically, no problem. Most of machines, guys, are required to have a disconnect. So you grab that disconnect, bring it down. So that's shutting it, and you lock it and tag it. So and not only the electrical, but also if you have high pressure gas or high pressure steam coming or whatever, any other source of energy, you have to lock him in the proper way. And you guys know probably about these more than I know based on the process. There are other sources of energy, nuclear energy coming from this side, or thermal energy, or chemical energy, whatever. You have to shut them down to work on this piece of equipment. And release stored electrical energy. Release stored electrical energy, guys. If you have a capacitor like this, and you want to work on the terminal of the capacitors, you know the capacitors are storage devices of energy. So if you know, which you should, based on the equipment that you work, that it has a capacitor, especially power capacitor. So you are typically, these power capacitors come with a set of resistors. When you shut them down, it burns the whole energy. So it has to release the energy out of these inductor or capacitor, or if it's a battery, you have to lock the plug. So you have a 24-volt battery, and you're going to work around it. So make sure you cover the parts of the battery, especially if you're a battery where you series them, and at the end you get 120-volt DC. You know, you put batteries in series to get 24. You're supposed to cover them. Typically, they come covered, and prevent contact with them while working in the area. So you release this electrical storage of energy, which is the coil and a capacitor. After you do that, and release or block non-electrical energy sources. So non-electrical energy sources, thermal, if you have to diffuse certain thermal things to release it, so while you're working there, it doesn't burn you. So there's other sources of energy. After you do that one, my friends, you're going to do apply lockout tagout procedures. So you go to your disconnect, and you're going to lock it with your lock right here. I don't have a lock here. And you tag it with your name, a tag and a lock, and one of these. Now nobody other than you can lock and tag. And by the way, it's against the law for somebody to go cut your lock. There's a procedure, guys. What happens if you forgot your lock here and they want to energize the object and you went home? What happened, right? People do that. So the manager have to come, they have to investigate, verify that you're not on the process, go to the equipment, nobody's working on it, and your manager have to sign it, then they go cut your lock. So there's you want to make sure that you are accounted for before somebody goes and mess around with your lock when you put your lock here. And I don't have a lock and a tag. You tag and lock it. And then attempt to operate the equipment. After you lock it and tag it, guys, you're going to go push start. Start's not going to start. Okay, and then you're going to verify the energized condition. Then you grab your voltmeter, and you're going to go to the load side of your disconnect to the equipment they're working on, and measure the voltage line to line, line to line, line to ground, down. And before you do that, what happens if the battery is dead on this and it's not working? So before you do that, you go to an outlet like 120 outlet, and you put yourself on a voltage here, and you go measure, and you expect when you go to 120, what do you get? 120, not 240, and make sure that thing is giving you to verify the operation of the equipment. That's required by the 70E, verification of the de-energization. After you verify by measuring the voltage is absent from this piece of equipment. Now the equipment is dead. Now it's completely in a safe working condition. Does that make sense? De-energization. But what people forget is test your equipment. That's why when you get your meter, the first thing you're going to go make sure that's working. Verify it's working. It's not just make sure, verify. By plugging it into a 120 outlet and put it in a voltage, AC, not DC, and measure it. And don't put it in amps, and put it on amps and measure voltage. Any comments, guys, about lockout, tagout summary? Now, you guys don't involved in this. There's here now. What happens if you're working on a process where multiple disciplines are engaged in that work and equipment, and it goes over multiple shifts? Could it happen? I don't know if you're involved in a situation where multiple shifts come work while the equipment is de-energized, and multiple disciplines. If you have a multiple disciplines and multiple shifts, or multiple shifts working on it, then you have to assign a safety coordinator to make sure that he or she will be in charge of the whole process and convey the information between all the disciplines as well as between the shifts. So it gets complicated when multiple shifts and multiple disciplines work on the same piece of equipment. And there's detailed right here how to do that too. But let's bury that one. Okay, here's your disconnect, guys. Disconnect here is the proper disconnect. The controller, can you guys see the off here? This is not, controllers are not approved as a disconnect means, acceptable disconnect means. So here's your acceptable disconnect means that can be locked in the open position and tagged. So turning the machine off is not an acceptable means of locking. So you have to go directly to disconnect. Some of your equipment, guys, might be the disconnect qualified as a plug. Unplug that piece of equipment. Now you disconnect it from the power source. A plug is a disconnect. Circuit breaker, certain equipment, in your case at the level voltage that you work, you can go to the circuit breaker, turn it off, and you put a lock on it and lock it. That's an acceptable means of locking it for smaller loads. For bigger loads, that's what you see, that big disconnect. Release stored electrical energy. The first and the most important guy is capacitors. Capacitors, guys, have enough energy to shock people or create fire. So stored electrical energy, it does store this one in an electromagnetic field. So discharge, you are to discharge it. The code requires you to bring the voltage below 50 volt in 1 minute. The power capacitors that we install, guys, by design, they're supposed to, if you were to lose a source of power, they're supposed to come down to 50 voltage within 1 minute by adding resistors on them. So when you lose the voltage source, 480 on it, you move the 480, they will be shunted into a bunch of resistors where they burn the energy through resistors. And that by manufacture, they build them in a way where you remove the power, the energy will channel, instead of storing them, it goes right into the resistor, burn it within 10 seconds, within 1 minute, drops the voltage below 50. Why 50? 50 is the shock hazard threshold. So must discharge to less than 50 within 1 minute. Power distribution, internal, they use internal resistors. Also shielded or coaxial cables can also act as a capacitors. You guys remember what a capacitor is, right? Capacitor is a voltage in one level and an insulation and a voltage in one level and the grounded object in the second level. In between is insulation, some type of an insulation, dielectric, right? So if you put a hot conductor here and an EMT conduit, right, grounded, and in between them insulation and air, that's a capacitor. That's what the inductive reactance for a power system is coming from. All these power lines in the EMT conduit and MC cable, right? Because the shield of the MC cable and the EMT conduit is grounded, and the conductor have an insulation and they have a hot. So here's a plate, hot, and here's a plate, which is the EMT conduit, and in between them insulation and air. That's capacitor. Not the best capacitor, but it could store energy. Anyway, coaxial cables and shielded cable can stored energy. I don't know if anybody has any experience with them. I don't have any experience with these, but can. But batteries obviously disconnect and insulate or guard the terminal. That's what you do with batteries. You're not going to go put resistor, and batteries are meant to store energy for use. So you disconnect them and you insulate or guard the terminals. That's all what you can do for batteries. Any comments, guys? Any questions? Other sources of energy, nuclear and chemical. That's a whole different story. You have to have process, guys, of isolating the energy that's coming to this piece of equipment. Do you have, I assume you have other sources of energy coming to the equipment that you work on? You know, air coming to it, steam, hydraulic, you know, that, so they have procedures for isolating it. A third source of energy, storage energy, guys, is in inductor. Inductor. These are coils. If you have a coil or a motor, they store energy as a magnetic energy, electromagnetic field. So be aware of that one. Comes out of motors and transformers, coils. So when you have a transformer, when you shut a transformer down, don't go immediately. You shut it from here and put your finger right across the terminal here. After you shut it, now you're going to get zapped with the inertia. It acts as a generator. When you shut the motor for a very short amount of time, the motor will act as a generator, generates power because it's stored there. So be aware of that one. If energized and if you energize it with DC, it will produce electromagnetic discharge, inductive kick. We do have a coil here, guys, for you. One of the exercises, we have a coil as well as a capacitor, and you're going to verify the voltage and the capacitor in the coil and put a resistor across them and see how the voltage goes down and what's not. So inductive kick for certain coils if you put DC on them. And if you have low voltage, that's why the NEC code book guys require you to put your low voltage conductors in a different conduit or cable than high voltage, because if you put a coaxial cable right next to the power cable, the higher voltage will induce voltage into the lower voltage, and you could have a shock from the induced voltage. Here's a bunch of other sources of energy that you have to pay attention to. Of course, you guys will pick and choose from all these sources of energy that you have to de-energize, from gas into water into chemical. And every machine is different. So when you go to work on the machine, you have to ask yourself, am I done with the electrical part of it? Yep. Now, how about hydraulic, pneumatic, mechanical, chemical, compressed air? Somebody said about air, you guys, steam, gas, water, residual thermal, gravity, things can fall. If you de-energize an object, some piece of equipment goes down to default. So, any comments, guys? Any questions about basically de-energizing, releasing the energy from all sources? Apply, lock, and tag. Here's a proper lock and tag procedure, guys. A lot of people use, I don't know, this is the most commonly used things. You probably guys use this. So they'll give you 6 locks to put here for 6 different people. So the mechanical contractor can lock it, the electrical contractor can lock it, the control people can lock it, up to 6 people. And when you're done, you go there, take your lock, and then no, you can't open this, right? Unless 6 of them are done with a piece of equipment. That's what's nice about these. It gives you 6 locks to work on, 6 disciplines if you choose, with 6 people. Lockout, tagout procedure, guys, have to be done by a qualified person. I can't send my 10-year-old son to lockout, tagout the piece of equipment for you. It has to be a qualified person. And we know what a qualified is. You have the knowledge and the skills of operation and the construction of the equipment, and have received safety training to recognize and avoid the hazard. Okay, verify the energization. Select, so now we talked about this one, guys. Shut it down. Select the instrument with the proper rating. That's the single most important thing, and do not use anything less than 3 or 4 in your case. Category 3, category 4. So that's the rating. Voltage rating exceeds circuit operating voltage. You would hope so. So you don't use a meter that says highest voltage 240 on a 480 system. So most of these guys are 600 volt rated piece of equipment that will cover from 600 volt down to 0, basically. Class rating appropriate for and then this is easy. The class rating is appropriate for the location in the system. The class rating is what we talked about, category 1, 2, 3, and 4. And that has to do with the transient and the short circuit capability of the piece of equipment. So they rate them based on how much transient voltages they can handle and how much short circuit they can handle before they turn into a big ball of fire in your hand. We talked about category 4. 3 and 4 is what you need. They can go from category 1, 2, 3, 4, 1 and 2. 1 and 2 is for benches work. 3 and 4 is you can work on them on panels and what's not. And test between all, look at this, test between all circuit conductors and between conductor and the ground. When you verify, guys, face to face, face to face, face to face, face to ground, to ground, to ground, to ground. That's it, done with a 3-phase system. So, and then verify operation of test instrument. And then before and after, you verify the voltage. Before you verify the voltage, you go to the 120 outlet, test it. Yep, it says 120. It's operational. Then you go verify, verify, verify. Done, right? No voltage. Then you go back and test your meter again. Does it still say 120 up? Then I have confidence in this piece of equipment. So that's how you're supposed to do it. So you verify before and you verify after. Then, and by the way, while you're verifying, you're dressed up. While you're verifying, you're dressed up, because until you verify the absence of voltage, the piece of equipment must be treated as energized. And until you verify it. We talked about the instruments, unknown sources of power. Any comments, guys, about using the instruments? Verifying. Labels for multiple power sources. There are pieces, I'm sure you guys have it here. There are multiple sources for a piece of equipment. Look at this one. This is probably for bigger systems, but look at that. We have a photovoltaic system coming to this building, multiple photovoltaic system. The NEC code require the panel and the equipment to have a disconnect, and the disconnect have to be labeled. Every equipment have to have a disconnect, and that disconnect have to be labeled. So you have a disconnect, it has to say air handling unit 1 or whatever. If an equipment has multiple sources of power, the equipment by NEC code must be labeled with the multiple sources of power. Now, that's if they install it right. So if you have a panel and you have 2 sources of power coming to the same panel, it should say 2 sources of power and where the disconnect are located. So when you lock them, what do? Do you go lock one source but not the other? Here's another story for you. I have a friend of mine, dentist. He decided to rewire his kitchen. So he went to the kitchen, a receptacle like this, gentlemen. So he went and, he shut down, right? The first thing you do when you take a receptacle out of the box, what do? You go turn the power off, the proper way of doing it. So to turn the power off, he verified the power is here. When he verified the top, I'm not kidding you, he's smart enough to verify the absence of voltage here. Do you guys know how we wire kitchens in the US? We have something called multi-wire branch circuits. So the electricians do multi-wire branch circuit. The multi-wire branch circuit bring one circuit here and one circuit here, one circuit here and one circuit. So we test this one, no power. He assumed that there's no power here. So anyway, so he grabbed it, I'm not kidding you, like this and took it out. Got the shock of his. But again, the short happened from shock from here to here. So he burned a little bit of his fingers, but he got really, really good shock. He was able to let go. It's 120, 20 amp. See what the verification is? There are 2 sources of power coming to the piece of equipment. These days, the code changes. Now, when we feed a piece of equipment like this, they have to be simultaneously disconnected. They put them in a circuit breaker with a tie between them. Now, but in the 70s, they didn't do that. And the same thing, we're talking about the old piece of equipment. You don't always have the luxury of working on new equipment with new code. So always verify the absence of power in all the sources. So if you have 2 disconnects coming to the equipment, verify that, shut them down and verify on the 2 disconnects, so 3 disconnects. Apply lockout tagout responsibility. Each person who may be involved within the equipment, directly or indirectly, shall use the appropriate lockout tagout procedure. So anybody who is involved in the equipment have to be. So if you have multiple contractors here work on the piece of equipment, they have to be involved. All personnel involved shall be trained in the responsibility in executing the procedures. You have to know how to lockout tagout. Follow up the up-to-date electrical plans in determining the lockout tagout procedures, verify actual points, coordinate lockout tagout procedures with all personnel for conformance. So if you're working a piece of equipment, multiple contractors, all of them have to be trained how to lock the equipment and how to apply the lockout tagout procedures. You have to inform the people who are going to be affected by shutting down that piece of equipment that they will be affected. So that's part of the requirement for lockout tagout procedures. For you guys don't get involved in that one, but the electricians that they do your system here, you have something called riser, electrical riser, or one line for the building. So electrical riser in one line, it tells you how the system is built, the power system is built. So you are supposed to verify, so it will tell you which disconnect something. So you are supposed not just to use the blueprint and say, yeah, I'm going to lock that one and start working on it, right? No, you have to verify that the blueprint is what's really is going on there. That's why you go through the whole procedure. First you lock, then you verify, because we discovered over the years, guys, that what's on the blueprint not always what's in the real life. Completely two different things. Okay, shall we give you guys 5 minutes and then we'll jump into that one. Thank you. Awesome. Okay, I'm gonna move on, guys, a little bit. So I have to finish. I need to give you 1 hour to do the activity. Otherwise, we'll give you enough time. So working in electrical hazard required for electrical for work involving electrical hazard. A couple of things that we have to do on the exception: voltage related. So there's a bunch of boundaries and insulated tools and PPE that you guys have to do. So now we decided we're going to work energized. How can we pick the appropriate tools and the insulation? That's the activity. And then after that, we're going to do the arc flash boundary and the PPE for it. So when you work energized, like I said, there are two different things. One is the shock hazard. One is the arc flash hazard and the blast. There's completely two different things. And you are to pick the equipment and the tools that protect you from both. Cool? All right, so let's go into that one. There's something called the boundaries, guys, and I'm going to limit these to a couple of things. Number one, there's something called let's see where the boundary is, right here, prohibited boundary. I'm going to highlight this one. This is number one, prohibited boundary. I'm going to call it number one. Can you guys see that? And then the second one is called restricted boundary, number two, restricted boundary. And the third thing is limited boundary. Limited boundary is number three. And the fourth one is arc flash boundary is number four. That's really, so if you have a piece of equipment, guys, right in front of you, here's the piece of equipment. Right here is phase A. If within an inch or two from phase A, that's called prohibited. Prohibited means the only thing can get within a couple of inches of an energized object is an insulated tool, which is not that one. That one, an insulated tool. That's the prohibited. That's only for tools only. Only tools. You don't put your finger right there, because the voltage will jump to your finger. Only insulated tools. That's called the prohibited. Can you guys see the boundary where it goes, the prohibited? Number one. Now, here's a couple of inches from the phase A, right? Now, let's move a little bit, an extra, say a foot or two. Now, we're moving a foot or two. That's called prohibited. So prohibited, the second one is called restricted. The restricted is a couple of feet away from the objects. The restricted, only qualified people can enter the restricted with their appropriate PPE. The restricted. Now the limited. The restricted is a couple of feet. The limited is even further, a little bit further, like 3 feet. That limited area, 3 feet around the equipment, only the people who are working with the equipment that qualified and in their PPE can enter this piece of that area, that circle. And then the arc flash boundary encircles everything. Typically, the arc flash boundary guys are bigger. So here's a piece of equipment. An inch is prohibited. A foot is restricted. 3 feet is, we call it limited. Then the arc flash is 4 feet. Encircle the whole area. So who cares? If you're in any of these areas, you have to pay a lot of attention to the tools that you use and the dress that you have. Okay, here's the how they define it, guys. You can see here's a panel. You have the prohibited here. That's your tool. Couple of inches typically. This is restricted. This is limited. And the arc flash. Look at the arc flash. The arc flash is assumed to be 4 feet, guys. Arc. They call it arc flash boundary. So you're supposed to get. If somebody's working on a panel, you're supposed to get 4 feet at least out of that panel, unless you know otherwise. So. Okay, so limited approach. Limited stock, like we talked about the limited approach, guys. Only qualified people can get into the limited approach. If you have an unqualified person, may enter the space briefly for a task such as handling the tools. So limited approach. I'm working on a piece of equipment. You're helping me. You can enter that. You're not qualified. You can enter to give me a tool and leave. The limited approach. You can sit there with me, and I'm working on it. That's your limited approach. And then remember, the prohibited approach is what? The tool. Limited approach is me working on equipment. Me working on equipment. And if you're unqualified, you have to be supervised and escorted when you get in. Restricted approach, this area, life part, restricted only to qualified people, the restricted approach. Under no circumstances, an unqualified person shall enter. So here's the panel, 3 feet. You can come within 3 feet of the panel to give me that tool. After I get closer, like a foot from the panel, that's called restricted. You can't get in. Now I get a couple of inches, I can't even get in. My tool only can get in there. That's the prohibited. Prohibited, restricted, and limited. Prohibited, restricted, limited. Prohibited for the tool, restricted for the qualified person only. And limited for the qualified person only, but unqualified can come and give you a tool and leave immediately. Okay, qualified person will have, and when you are qualified and you are in the restricted, you have to have training for the equipment and the PPE. You enter the restricted, guys, you have to be suited up right here, put your suits on, and you have to be trained with the hazard that this equipment can initiate you. We talked about the prohibited. Prohibited, if you get closer than a couple of inches of that phase, the voltage will jump. Not just, don't touch it, it will jump and grab you. That's where the tip of the screwdriver, the insulated screwdrivers can go right there. So closer can do flashover, they call it, flashover, to conduct the parts. Considered, and it's considered if you get a couple of, depending on the voltage, a couple of inches from a phase is as if you have just a phase. It touched the phase. That's what the prohibited is. You know, you get closer, you might as well touch it. So, and if you're in there, qualified person have specific training. You have to have the presence and the presence of voltage. Used to avoid the exposure. You have to have the PPE for the system required. So you enter there, you have to have the right tools when you're working there, the PPE on you, and you have to be able to verify what you're doing. You know what you're doing when you're qualified, and you can verify that this is hot, but this is not. So you have to verify the voltages on the system. Any comments, guys, about the approach boundaries? Here's an example. Let's take you guys. You are most likely right here, right? This is the table that you guys. There's an exercise about this table in a second. You are nominal system voltage face to phase. You guys don't have face to phase, so for you will be face to ground. Right in here. So look at this. Limited approach exposed. Ignore this, because that's for the guys. Exposed fixed. You guys are right here. Exposed fixed circuits. Look at that limited. This is your limited approach. Limited approach is 3 feet and 6 inches. How about restricted approach? Restricted approach including blah blah blah. There is no limit, but just don't touch. Prohibited approach, also don't touch. Can you guys see that? Best for you guys. Just don't touch it for both restricted and prohibited. Now let's just take you to another voltage level, which is the higher, the line side. Now look at this. You have right here, you have 3, same thing, 3, 6. Now this becomes a foot, and this becomes 1 inch. So remember, this is where your panel is. and these are where the distances are measured from. So here's each one of these. So the first one, the prohibited is right here. This is number 1. Number 2 is here, and number 3 is right here. So this is number 2, and this is number 3 in terms of measuring. Any comments, any questions, guys, how to use this table? There will be an activity, how to use that table to measure the boundaries. Now remember, the arc flash boundary will actually encompass the whole thing. The arc flash will be right in this area, which is either 4 feet or calculated by your engineer. If it's not calculated, you assume if you have a panel here up to 4 feet, that area is an arc flash area. Means the ball of fire will reach up to 4 feet from that piece of equipment, unless you have calculation that verify otherwise. Because these are, remember, these are not the arc flash. Okay, voltage rated piece of equipment. For voltage rated, guys, we use gloves, sleeves. I don't think you guys use sleeves. Blankets. They put sleeves in these power lines. You guys don't work on power lines anyway. Your gloves here. Hose. For you guys will be the gloves for the most part. Insulated tools, hand tools, test instrument, and hot sticks, typically over 600 volt. So your hand tools, insulated. We looked at these two for insulated instruments and the test instruments. Okay, here's the gloves. You guys use gloves, right? 3M has gloves for you. Here's the gloves requirement. You are looking at class 0 here. Here's your class 0. So look at class 0, gentlemen. Class 0 can get you how high you can touch. So you grab a class 0, and I can, with my bare hands right now, I can touch up to 1,000 volt AC or 1,500 volt DC, like this. This is insulation. Now the other one is, this is a class, it's a black, class 1. This guy is 00, I believe, if I remember right. Yep, 00. 00, you're right here. This is what most people use. That will get you up to 500 AC, 750 DC. So now I grab 500, that will cover all the voltage that we use in the US, up to 480. I grab, here's a 4,000 amp gear, and I go grab it like this. And this should insulate me from it. It should. Would you bet on it? Yeah. But now remember, this is to insulate you from the shock. But what happens when you have arc flash? This will melt. So the smarter than Chad say, hey, you need to protect. Now this to protect you from the shock. Now you need to protect yourself also from the arc. So you put this one on, right? I'm sure you guys use it. And then now this guy, now you're fully protected from the shock and the arc. At least the feet, not here. Does that make sense? So you are to protect, this is to protect you from being shocked. This is to protect, this is the rubber gloves. And this one will protect your rubber gloves from being damaged, number 1. And also if you have when you have an arc, protect you from an arc flash. Category 0. Anyway, so it goes all the way to category, God forbid that you guys are running around with the category 4. You've seen them, the guys on big ones. So they come in 2 types, natural and synthetic, and I'm going to spare you guys the 2 that you're working, that you looked at, they come in synthetic. They are easier to tear, more flexible. Okay, so here's those guys who they ASTM labeling color. You guys look at the black. Here's the black and the orange here. They're labeling color for these. Can you guys see it goes by voltage? Different. This is just their standard. They give it a different color code for the gloves. So here's my gloves right here. Glove labeling, the type as well. Here's the 00 here, and here's my 0, and the color and the type and what's not. I'm going to spare you that one.
So when you said that the orange glove is good for the 500 to the 750, that's live, right?
Yes. Everything is live. Yeah. If it's not live, I can go with my hand, grab it. Yeah. Everything is live. Live and exposed, meaning you're copper, you're looking at copper and you can grab it with your hand. I wouldn't do it though. Just because you can. Okay, use and care of rubbers. A couple of things about the rubber guides. The storage, you have to store them away from moisture, otherwise you damage them, and dirt and heat and what's not. And always use leather protector. Remember, you have to use, this will protect you from shock, and this one is to protect. So your leather protector with rubber gloves. You have the combination of the two, basically. And that's why we use these two together. One shock, one arc flash. And also, this will protect this from being torn when you're working on it, because these are very sensitive. You tear it, now what happened to the insulation? You damage the integrity. Always use the other protector, not to be used as gloves. Protectors not to be used as gloves. This is not using this like this. This is not insulated. You're not supposed to work like this. This is to protect this. The proper protection. Huh? Was he? Well, no, they have one inside it. You would see it. Yeah, they typically, or their category will be rated different, but we'll ask them. Yeah, but typically you have to have two. They typically have one to protect from shock, one from the arc, or to protect the rubber. And then test before you use. Air test, you're supposed to blow through them and test if there's any leakage out of them. Then they're compromised every time you use them. So and laboratory test every 6 months. They made it really expensive. I mean, you have to test them in the lab every 6 months too. So every time you use it, you blow through it. So guys, they're making it very hard for people to work energized. They really don't want you to work energized, especially on a lot of stuff, especially the power. Okay. Tests. We talked about how to test them. Laboratory test requirement by voltage PPE. Look at this. We don't have blanket for you guys. The gloves, when installed values is when insulating values suspected, and also you have every 6 months thereafter. That's where you guys are. You are supposed to lab test them if you suspect that something wrong with them. They leak air basically, or every 6 months. Do you guys use sleeves and line hoses and that? You probably don't. Okay, non-insulated tools. Gentlemen, you're looking at them right here. Comfort grip, these. And insulated tools, you're using them. These are voltage insulated. I'm losing my vision here. Yeah, if you look at it, client, it says 1000 volts. So literally, I can cut right here through a 1000 volt. Make sure you're dressed up for it though. Or I can go torque a lug with this up to 1000 volt. So yeah, with the gloves, with the gloves and remember, these are just shock. These are supposed to protect you from shock. Remember the arc flash. The arc flash will require you to have this and the suit and whatever needed else. Okay, defining arc flash hazard. Now this is the shock. Any question, guys, about the shock before we move into the arc? The shock is easy. All what you have to do is grab these two together when you're working energized and grab insulated tools, and you're good to go. That's for a shock. Don't touch anything with your elbow. So if you grab these two, you're protected from the shock. Now we're going to go to the arc. The arc will force you to do what? To put this one on, because there's a big ball of fire coming in the tip, and use other things. Okay, here's the arc. Incident energy. They call it incident energy, guys. Radiated energy on the torso of a worker exposed to an arc flash measured in a calories per centimeter. The way they measure them, I think it's 18 inches. They assume you're working on a piece of equipment and your chest here is 18 inches away from the panel while you're working, and the energy is going to land right on you. And that's the amount of energy that they put categories for all these A-rated gear, clothes that you wear. They're assuming, this is on the test too, 1.2 calories per centimeter is curable burn. If you land 1.2 calories heat per centimeter on your flesh, that's curable. Curable. More than that is non-curable burn. That's their cutoff. So everything here is based on cutoff of 1 calories heat per centimeter. At an 18 inches, when you do the calculation, 18 inches away from the energized object. Okay, the amount of current flow. So instant energy, the amount of current flow. So how high energy you can get. The higher the flow, very easy. The higher the current, the more energy. The longer the time, the more energy. That's it. So if I have an arc right here, you guys don't get into setting up the circuit breakers. Circuit breakers by default to 3 cycles. So 1, 2, 3, they trip. And that's not 1, 2, 3. 3 cycles is 3/60. 3/60 is 1/20th of a second. A circuit breaker is supposed to trip within 1/20th of a second. That's how they're set. Some fuses are faster than that. So 1/20th of a second, guys, is an eternity in terms of arc flash. That will allow a lot of arc flash. That's why you have the energy limiting or current limiting fuses where they can cut within, instead of 1/20th, within 1/40th or 1/60th of a second. So the higher the time, the more big ball of fire can chase you. So, and that will be controlled directly by the speed of the overcomputation devices, which you guys don't deal with that. Okay, fault current and IC interrupting current rating, arc flash and the amount of fault, and so it depends on the amount of fault and the duration. The fault, somebody asked about the fault. The fault is typically, guys, the design engineer. We have a software called SPM. What they do to a building like yours, they come and they take the power, they put it in the building and tell you, yep, this will be category 0, 1, 2, or 3, or 4. Based on the calculation that we do with the short circuit coming from Excel Energy to your building and the feeders in between, and where this piece of equipment is located compared to the service, how far it's located from the service, what type of feeder, how big of a feeder, all these will decide the short circuit. Duration of the arc is determined by the upstream fuse and circuit breaker setting. So the lower the setting of the fuse, the less arc flash you have. So, and you guys probably at what you do, you don't have control over this. Okay, a simple circuit like this, guys, probably is a 20 amp control circuit. Under normal circumstances, from the Ohm's law, we're pulling 12.5 amps. Now you go short it, take it to ground, take hot to ground. Look what happened. When you take it to ground, what happened is, can you see the impedance? I don't know if you know how to calculate the short circuit. Based on the impedance, you take the full load amp of that transformer and you divide it by the impedance. That will give you the amount of short circuit that will be pumped into your system. That's bad news. That's how much we went from, look at this. We went from 12.5 amp to 2000 amps. Now, 2000 amp for a very short amount of time, 1/20th of a second. But that's enough to pump that big ball of fire at you, throw that big ball of fire at you. So power circuit designation, they start, guys, with the service right here. So here's your 4000 amp service, 4000 amp service. Right at the service, say it was 65,000 amp interrupting rating. You go down to this 225 amp panel, 225 amp panel. The short circuit here will say like 35K. Now down to your piece of equipment right here, or your piece of equipment here. So let's say that was a 60 amp circuit coming to this piece of equipment. Now the short circuit right here could be as low as, say, 5K, 5000 amp. And I assume you guys will be right at this level here, right at the level of equipment. So it's the lowest amount of energy that you exposed to. So where you are, if you're dealing with the short circuit 120 control circuit, you guys are within 2000 amp short circuit, very little. If you're doing in the panel, you don't do residential, but if you are inside a 480 panel, you're a higher short circuit. So for you guys probably will be where you work on the control circuit will be 2000 amp or less, which is less amps, smaller ball of fire coming out of it. Now you open the panel and you start working on it, you're exposed to 35,000 amps instead of 2000 amps. Higher amp, more big ball of fire. Circuit breakers, guys, are rated interrupting rating, typically 10, and this is 2000 amp fuses, 200,000 amp. So that's that's how much a fuse or circuit breaker can interrupt before it turns itself into a ball of fire. You know, and that's done by other than you, but be aware of that one. Arc flash thermal PPE requirement. When inside the arc flash, you are required to have a PPE under the following circumstances. If you are within the arc flash boundary. Now remember, the arc flash boundary is 4 feet unless the engineer calculated. 4 feet unless it's emphasized. We have software that can tell you guys. Sometimes it goes 6 feet. 6 feet, meaning 6 feet. Don't get into that 6 feet from the equipment unless you're working on it, unless you're dressed up. Energized parts are exposed, and energized parts exposed, or interacting with equipment where energized parts are not exposed, but the increased risk of the arc flash exists. So you're dealing with equipment, you're working on equipment, and there is a chance that this equipment could arc. So then you have to put it on. If I'm walking by switchgear, guys, and the switchgear is not open, I don't have to dress up. I'm not working on it. I'm just walking by it. But the minute they open it, now you're exposed to energize, and you open it, and you're in front of it, and you're within 4 feet, you have to put that gear on. Okay, personal protection. You have to protect your body, your hands, face, and eye protection. The clothing should be flash and flame, and should not be support burning. Untreated natural fibers like cotton and wool and linen, these are what you need. Steel toes must have leather covering because you don't want to be conductive, remember. And the shock resistant shoe when working on live parts. So they have to have, especially if you're working on live parts, you guys don't get into on that one. And you have a steel toe required to work in the environment. It has to have enough insulation in it, not to make you a conductor, to make you part of the circuit. Okay, this is also on the test, guys. Hazardous categories. This is just calculating the energy. Look at that. There are 200 calories have been calculated, though 40 calories are the limit. And we know what 40 is the limit because after that, they can't protect you from the push, the energy that comes out of it, the blast. All right, so category 0, less than 1.25. That's also on the test, guys. Category 1 take you up to 4, 8, and 25, and 40 are category 1, 2, 3, and 4. So 0, category 0, you're going to see how you dress up for 0. 0 is nothing. You dress up just with long sleeves and eye protection. You'll see it in a second. Category 1, 2, category 2, you are getting into this point when you get into the category 2. But they measure it based on, like I said, based on how much heat can land on your flesh per centimeters. So 4, 8, 25, 40. 1, 2, 3, 4. 0 is less than 1.25. Okay, here's category 0. Category 0, you're supposed to have protection for your eyes and hands, and the hands, and of course you have to have some type of cotton clothes that cannot ignite, and non-conductive shoes. Non-conductive shoes. That's the minimum. That's what you guys should be working on any energized object. And the gloves that you have in his hand is these two together. Just be aware. You have this and you have this. You can't have this by itself. You can't work with this by itself. You need to protect the leather. So that's your category 0. That's typically mostly what you guys are. If you're working with a 20 amp circuit, you are category 0. So that's typically, you protect your eyes, you protect your hands with the gloves like this, and you have long sleeves jeans, and a shoe that's not conductive, non-conductive shoe, you're good to go. Yeah. Yes, absolutely. arc rated shirt. Well, they don't ask you for category 0 yet, arc rated shirt, but it's
Can you have a cotton shirt over a polyester shirt, or do you have to have, so I see people put on, they put on a shirt over, but if you have the shirt under, it's.
yeah. There's layering. They call it layering, where you put layers over. You can put yeah, you can put one underneath to protect yourself, but you don't want to wear anything that could melt.
You should really take off here. If you have a polyester shirt on, you should take that off.
See, the problem with category 0, they don't require arc rated for category 0. It's not required to be arc rated at all. But it doesn't have to be arc rated. So, but it has to be it doesn't burn. The arc rated, and when you start getting into like category 1, 2, 3, 4, you start getting it. They have to be not only non-flammable, but they have to be arc rated shirts, like long sleeve shirts and what's not.
To answer your question, so yes, we actually have treatment for some of this. And so we're doing our rated shirt. So if you're going to work, you can put the arc shirt over top of your polyester because it actually insulating, in addition to not burning, it's insulating from it. So the shirt that's underneath won't see that, you can tell it sees what it's
rated for.
what it's rated for. So that's what they say, if you wear an outright cotton shirt, you put that on over top, and what they're providing us is arc rated, and it's okay.
It's not going right through it. It's
Right,
not
so
cutting.
But for 0, do you need that?
You don't need that, but you should be wearing a cotton shirt, not
Yeah.
not a polyester or synthetic shirt. And I wouldn't just put the cotton shirt over top of the synthetic type. Because the cotton shirt is rated to handle, will insulate from the heat and not burn.
I don't know if I have it for you guys, but I'll send you a description of what each category needs instead of the clothes. So you can good.
This question comes down to, if I say I have on, it's not a cotton shirt, a synthetic fabric shirt.
Yeah.
If I put a cotton shirt over top of it, am I then category 0?
Yes.
You're
Yes.
category 2,
Yes.
you put a-
Yes.
I'm actually even one less than that, and saying, if I have a polyester shirt on, I'd be going to category 0, but I need to put a cotton shirt on.
Yes. Yes. So now the category 2, look at that. Now you're getting into the arc rated shield, arc rated equipment. And now you get into category 4. Now your underwear right here have to be non-flammable, not kidding you. And all the stuff nothing has to be unflammable, everything non-flammable right underneath it. That's where you get into. And look at the categories that you have. So, and look at the cover of the neck here compared to like here, the cover of the neck is not a whole lot cover. So these are, like I said, you guys most likely would be in this category, and if you're working on the line side, you'll be in category 2 for the equipment that you do. You're in category 4 if you're opening a switch gear. Do you guys open a switch gear, like a 480, 2000 amp switch gear? That's where category 4 is typically. Okay, so arc flash hazard analysis, equipment labeled. By the NEC code book, guys, you have to mark the equipment with the incident energy and the proper PPE. This will force you, all the panels by 70E has to be labeled with the arc flash boundary, say 4 feet, and the amount, the category of the clothes that you have to dress up as in category 0 or 4, 0 through 4, and the gloves that you need. Methods to determine that one. We have 2 methods to determine this. Either you use our friends in IEEE 584 document 1584, or you can use the tables that you guys are going to be using later with Chad. My God, where does the time go? So there are tables or the IEEE 1584. 1584 has a software that's called SKM. We plug it in, guys, and it will bit you beautiful bits for you, beautiful labels like these that you can go print and put them on the table, on the equipment. So the flash protection cable in the NEC code book, guys, right here, it will tell you that all equipment, and I'm going to remind for you guys, would be industrial control panels. That's where you guys land. Industrial control panels must be labeled with arc flash warning. Now this guy goes further than that. It goes in the label, it has to tell you the category 0 through 4 and the boundaries of the arc flash. Is it 3 feet or 4 feet or 1 foot? Here's what we're talking about, gentlemen. The label that you've seen it all the time. Arc flash boundary for this piece of equipment is 24 inches. And the it's category 3. That's exactly, I showed you category 3. You need, here's what you need. 1 layer of 6 ozone, whatever that, and leather gloves. The PPE, you need leather gloves, face shield. Cover is, this is when the cover is removed. And look at the limited, restricted, and prohibited approaches that we talked. The software will calculate this for you. And you stick it onto these system. And here's the rating of the gloves that you're supposed to do. So that will be 0, 0, this type of gloves if you're working on it. So remember, guys, this part is to protect you right here, to protect you from the shock. And this part here is to protect you from the arc. So there are 2 parts, 1 shock, 1 arc. Any comments, any questions? This is required on every industrial control panel.
So you said category 3, but that's not category 3. It's 3 calories per centimeter squared.
I'm sorry. My apology. Yes, it's 3 calories per centimeter. That will be less than category. This will be category 1 because either 0 or 1. The next is 4 is, what is, 1 is up to 4, right? Yeah, less than 4. That's category 1. Thank you. I was looking at, yeah, it goes by the calories right here. Thank you. So 3 calories per centimeters.
So next line down, it says 1 DF PPE level. Is that the category PPE level you need? Is 1 DF?
Category 1. This is I'm not used to the language. The software that we have label it with exactly 1 category. It says 1 category. I assume this is what they use. One is 1 DF category PPE level 1. Yep, that's level 1, category 1. And the layer 6 ozone and the leather gloves. I assume the PPE level 1 is category 1, definitely. But I'm not sure what IDF is. 1 DF. But PPE level 1 is category 1, which take you up to 4 calories per centimeter. Okay, so you guys have a bunch of tables they're going to be using. Gosh, where'd the time go here? There's a table. I gave you guys in one of the activities this table. And you're going to be selecting select the equipment category based on the voltages, select the task, and the hazard involved, and the insulated gloves and insulated tools. For example, here's the category. Here's where 0 is. Look at 0, high defined. You were talking about 0. 0 is non-melting, flammable material, untreated cotton, wool, bran or silk or blends of these with the fabric. See where you have to use the cotton non-melting side for category 0 we just talked about. But you jump into category 2, you start talking about fire rated or arc. You start jumping into the arc rated equipment, guys, after category 1. But up to 0, all what you need is just cotton, like you just said, something that doesn't melt on you. Does that make sense? You have it. You guys have that slide. Now, everything else after that, I want to bring to your attention, guys, the FR is actually FR, fire rated or arc rated equipment, arc rated equipment. All of it has to be arc rated equipment after this category. Look at the category 1. It says fire rated shirt and fire rated pants or fire rated coverall. Look at this category 2, cotton underwear, conventional short sleeves and pre-flexion plus fire rated shirt and fire rated. So they're getting to the underwear here. So can you see it after category 2, they start getting into what you dress underneath it too. Any comments, guys? Any questions about the dress for the categories? So pay attention to the arc rated. Okay. Employees' clothing shall. So now the employer shall ensure that the clothing worn by the workers exposed to the possible flame will not increase the extent of the injury. That's why your employer, if they see you working on and you're wearing something that can melt on you, they should remind you. Clothing contain the following: shall not be, may not be used, depending, unless treated and certified as fire rated or arc rated. If you have hair necklace and cover and all this stuff, you're supposed to remove them by code. Hair nets, hair covering, and hard hat liners must also be fire. No, these are must also be fire rated. And if you have jewelries, you're supposed to remove them. Now they have to be fire rated if you're in category 1 or higher. Remember, if you guys are category 0, you don't have to worry about it. You don't have to put anything like this. Just the gloves. Okay, so here's where you guys are protected. Based on that table, we have the safety glasses, we have the ear protection only if you have sound. If you prove that it makes sound, you have to ear protection. Long sleeves shirt, leather gloves, and pants. All of them non-melting. That's to answer your question. That's category 0. Non-melting or untreated fiber clothing, such as untreated cotton, blah blah blah. So anything that does not melt. But if you have arc-rated equipment, you're done. I mean, if you have an arc-rated shirt, you don't have to worry about what type of cotton you have, treated or non-treated. We talked about all these guys have to be removed while you work on energized. Watches, rings, earring, chains, eyeglasses, connect eyeglasses like these. You can't work on the energized. Keychains. These are by code, believe it or not. Energized work permit, and I'm running here because of time. Required when? When do you need an energized work permit? Now remember, any comments, guys, about the arc flash and the equipment and selecting and what's not? The categories. You have an activity for you to pick the categories. In a second, we're going to be using it. Equipment. So, energized work permit. Equipment or circuit cannot be placed in electrically safe condition. If you can't lock it, tag it, and do it through the process, you have to do energized work permit. Exception to OSHA, not the rule. And the work is crossing the limit. And if you cross the limited approach or the arc flash boundary, limited approach or arc flash boundary, you have to have an energized work permit. Or working with equipment will increase the likelihood of an arc flash occurrence. So that's where you have to have an arc flash boundary, and there is exception for these ones too. So basically, every time you work energized work justification for not de-energizing, you have to. So when you go through it, guys, it tells you why can't you work on it de-energized. That's the first thing. You have to, on record, you have to justify why can't you work on it de-energized. Result of the shock and arc flash analysis, you have to verify what type of installation you have to use based on the voltage and what type of PPE you have to use for this equipment now. And then you go into the voltage approach boundaries, the boundaries that we talked about, and there's tables that identify it. Arc flash boundaries, arc rated equipment, and required PPE. Means of restricting access, so you have to also how are you going to restrict the public access to the piece of equipment while you're working on it? You know, barricading it and what's not. Evidence of the job briefing. You're supposed to communicate before you work and energize. And again, these are, you guys are the exception in troubleshooting. But if you take a switch gear, you sit there with your crew and briefly de-energize. How are you going to release the people if they got electrocuted? And do not forget that we're going to sue you, so you have to put the signature, the approval signature for all the people who are working on it. So they really they're making it very hard for a manager to say for an apprentice, go open that panel and change this circuit breaker. You know. Any comments, guys, about energized work permit? You guys, I believe at 3M, you use the hazard analysis record to be your part of your energized work permit. Exception to the energized. Let's look at the exception. When didn't you do that one? Exception. Work within the limited approach. If you work within the limited approach boundaries, such as troubleshooting, voltage testing, if performed by, of course you have to be qualified, using safe work practice and PPE. So you're not torquing a gear, a circuit breaker. All what you're doing is troubleshooting and measuring. You're not Working means, guys, you take all your control circuit 120 and you start taking them up, you're turning them, unlock, what do you call it, untorque them and unstill them and torque them again. Now that's work. Testing, so when you're testing for voltages or troubleshooting, pushing buttons and troubleshooting, you don't have to have a energized work permit. But I believe you guys have the 3M, you have to do through the review record, the hazard review record to do any type of work because you have a lot of hazards too. Crossing the limited approach boundary for visual inspection only without crossing the restricted approach boundary. So you are walking in there and you're just looking visually inspect the equipment. You don't have to have the work energized permit. But if I want to open the cover, guys, and look at it, I'm not going to do anything. Just look at the equipment. I still have to put my PPE, you know, the proper PPE on. But I don't have to write an energized work permit for that. If you're doing troubleshooting, you still have to put your PPE, but you don't have to, the proper PPE, which category 0 for you, but you don't have to do an energized work permit, at least this time. Okay, for you 3M guys, 3M called area hazard analysis. I think we showed you that one. Identify the hazard in a particular lab area or mitigate the measures. Use the energized work permit for identified hazard, part of the guide. So this is where your equipment, guys, exist. And I'm going to jump in here before I talk about this one. My God, where did the time go here? Okay, here's the piece of equipment that you guys fill. Here's 3M hazard review. Anybody filled this one? Did you guys, anybody fill that form? You did? Any? That's what they told me that you guys are doing. It's called 3M hazard review record. So you look at the signature hazard review title, primary investigator, department, business unit, and what's not. Let me just take you down to, here's one room. It says, oops, I'm not going to move that one. Look at this, electrical, and we're interested in electrical. Most work is performed on enclosed system and or de-energized. However, some live exposed electrical work is performed by the developer. 120 is encountered. Look at the voltages. Then safeguard, electrical safety training. So if you are to do this, you need to have gone through Chad's safety training. So you can know how to put the PPE and whatever that you need to do. So these are a few things. Look at this one. This category, guys, work is performed enclosed, de-energized object. Let me see what, and or less than 60 volt, but you have to do lockout, tagout procedure. So that's what you guys fill when you do some type of work. This is all work permit that you do. There's another one. Here's another work that require PPE in this room. So use of PPE for electrical work. They're telling you what type of PPE that you have to fill that you need to use, plan to mitigate the risk, and what's not. So are to be available for those situations that might warrant use. They should be used in any voltage in excess of 50 volt. So does that look familiar to any one of you guys if you any filled? That's what they told me that you use these equipments, and that's and a couple of questions that you have to answer about different type of hazards here. So any comments, any questions about your area hazard area analysis that you have to do for this lab? So that's all right. Selection and use of testing equipment. We talk about the voltage, the category, and the type of the probes, guys. Here's the voltage categories, and there's category 4. Let me write in here, you guys should not use anything less than category 3. I'm sorry, category 3. Category 3 at a voltage level of 150 can handle up to 2500 amp short circuit. Surge capability. So these are volt. Surge capability. So category 3, if you have 600 volt like the line side, it can get you up to 6000 volt. A voltage is a surge. You guys are familiar with the surge. A lightning hit the transmission line, and then the voltage, look how beautiful the voltage was. Nice, going like this, right? And then you get all of a sudden you get a surge, then the voltage goes all the way up, all the way down, and goes, and then the surge gone, and now you go back to normal. That circuit breaker can handle up to 600, 6,000, 10 times more voltage because of a surge. That's why these explode. If they get more surges, if they're not rated for this surge, these little ones, they will short. They will ionize the air and short and explode. Any comments, guys, about category 3 and category 4? The probes, application of the probes have to have an insulation at them at the end. These don't have one, but typically they have that end have to have an insulation in them. These are the safest probes that you can use. Okay, we talked about you don't want to use this one a lot. Electronic equipment, low energy equipment, blah blah. Appliances, portable tools. This is the one that gets you the full protection. You don't have to worry about. Category 3, distribution panels, motor control centers, and short or heavy branch circuit. That's probably where you guys are most of the time. Probe type, the voltage rating, your probes have to be rated for the same voltage. So if this is 600 volt, these have to be rated for 600 volt. Can you guys see the insulation right at the tip here? Mine don't have this. So the ones, I'm sure you have the one that goes, you have to push it up to get the tip of it. So that's insulated, that's safer. Finger safe. Insulation connection, and inspect and test before use. Every time you have to use them, you have to make sure they test them, make sure they're fine. Nobody cut it for you, and just make sure it's expose some stuff. So you have to test your equipment before you use it. Any comments, guys, about the category 3 or 4 that the safest that you can use for this type of equipment? So that's your equipment. GFCI protection, guys, can also protect you from a lot of stuff. Like I said, you are an exception because you have a process. But if you can use GFCI for your equipment, you should use it because it provides extra protection from the shock hazard for people. And you know how GFCI works. It tested the current that's coming in versus the current that's going out, and if there is a difference within 5 to 6 milliamps, it measures it, and it has a brain that sends the signal right here to these little contacts, and it opens them and interrupts the circuit. Why 6 milliamps? Because that's the threshold that can kill. After that one, it could be lethal. If you have GFCI protection, guys, in your equipment, I don't know, do you guys have any GFCI on some of the equipment they use? Typically, if you have a process, you don't want that one because it could interrupt the process. If you have GFCI, make sure the GFCI will not protect you if you grab phase E, the phase, and the neutral, like this. GFCI wouldn't even wake up. It will have 5 amps going in, 5 amps going out, no problem. So, nuisance tripping on some equipment, that's why we don't use them in a process that's chemical process or what's not. Labs exclude them because they could nuisance the trip and interrupt the process. Okay, moving on to, guys, I'm gonna go very fast through the safety related work practice for electronic equipment. These are the article that talks about arc welding. You guys don't have a whole lot. Do you have power radio and antennas and television? What's not? Industrial electronics, probably you have a few. Show wave, VFDs and UPSs. This is the difference between the effect on people based on the frequency. I'm just going to put the 60 and 10K. For example, the painful shock leg go through. That's my favorite. Leg go through. If you have a 150 fat guy like Chad, 16 amps we talked about, but if you put a signal of 10 kilohertz, you can handle 37 amps. So, meaning if you have, now this is for higher frequency power signals. I don't know if you guys use higher frequency. I'm sure you use somewhere high frequency power signals. You can handle more. So I'm going to move through that. Hazard associated. You can have high voltage from them, radio frequency energy, induced high voltages too, radio frequency field, shock and burn, ionization for X-ray, non-ionization, radar, and also these are, I don't know if do you guys have any of these hazards? These are Article 340 talks about particular hazards from RF radio frequency and the X-rays and what's not that could happen. Employer responsibility. Your employer, guys, is responsible if you have any of these to get you proper training and supervision for these particular equipment. Proper insulated equipment, we talked about that, proper access to the equipment, availability of the correct tools, proper identification and guarding. By the way, these are not just for these equipment, for everything. Complete and accurate circuit diagrams to identify the hazard, maintenance of clear work areas, and adequate illumination. That's a requirement of the employer. Employee, now you guys, what's your responsibility? Understand the hazard. You're supposed to go, when you go through the training, pay attention to Chad, not sleep. So that's what they're saying here. Be continuously alert and aware. Use the proper tools and the procedures. Inform the employer of malfunctioning protective measures. Examine all the documents relevant to the work, identifying the hazards. So can you guys see the difference, you and the employer? So you have your share. Safety is your as an employee, safety is your responsibility first. You know, employee responsibility: maintain a good housekeeping, report any hazard, and use and maintain the proper PPE that given to you. Research and development labs. This is talk about research and development labs, guys. A requirement of this article shall apply to installation, specialized equipment designated for facility management, research and development lab. So here's, look at that. Each lab system shall be assigned a competent person. As defined in this, we define a competent person to ensure the use of appropriate electrical safety required practice and control. And I'm sure you guys have a competent person who gets you into the training and assign things for you. Competent person, here's a couple of things about your competent person. Person meeting all the requirements of a qualified person first, and has to be responsible for all the work activities or safety procedures, and has detailed knowledge regarding the electrical hazard, exposure control of mitigation. So now you're getting into a lab and research. There's a lot of things. This is not just a panel. There's a lot of things, a lot of energy that can get in. So you have to have a detailed knowledge of what's going on in that lab. Listing requirement: all the equipment that have to be used in the lab must be listed and field verified. Listed and field verified. That was on the test. Field evaluation: all the evaluation of non-listed equipment. So if it's not listed, came from China, it has to be field evaluated before it's installed. We talked about listing, guys. I don't know if you use Factory Mutual FM. I'm sure you use a lot of UL listed equipment, right? Everybody has to. Field evaluation: a bunch of smart engineers. Chad is not one of them, but they can come to your facility and they can evaluate the equipment and give you equivalent listing. Electrical safety program, the last thing, guys. When you guys have an electrical safety program, your electrical safety program have to inspect and evaluate the equipment you use for inspect and evaluate area hazard analysis. That's your way of part of your electrical safety program, the way I understand it. Maintain equipment and enclosure integrity. It's not enough to work on equipment, guys, safely. I always say, I know we're almost running out of time here. It's not enough to work on equipment safely. The equipment has to be designed and installed safely. So when you design a system, the system have to be, if system have to be designed and installed safely based on NDC code book, then it has to be maintained annually safely. You can't just throw the system and not maintain it and expect it to be safe. It has to be maintained safely. And then after that, gentlemen, you start working on it safely. That's how you guarantee safety. And you have to also, the equipment that you install have to be safe by being UL listed or any other third-party verification. Does that make sense? Safe equipment by listing, safe design and installation by NDC code book, and safe maintenance by that 70E or your maintenance program, preventative maintenance program that every building have it. And then you have safety working program by 70E. Okay, so maintain equipment, then plan every job. That's where 70E comes. Planning a job and document the first time procedures. The energize procedure, lockout, tagout procedure, that's part of your safety. Protect against the hazards. Anticipate unexpected events. So expect the unexpected to happen while you're working. So have plan B for things. And use the right tools for the job. And we talked about these, gentlemen, and assess the people's ability. And as a manager, you have to assess, are they capable of doing this type of work, locking, tagging, work on this equipment or not? So that's a summary of every electrical safety program that's part of your typically part of your maintenance program. So that's the principles, the control. Here's the control. Now treat all conductor as energized until you remember how they de-energize. De-energize and test all the circuits. Employer develop program and provide training. That's why your employer, guys, part of your safety program is here. Employee have to apply the program. Employee are trained. You have qualified person. You have to be trained. Tasks are identified and hazard assessed. That's why you guys have this area hazard record. And appropriate precautions are taken. So now we have the principles that we have to follow. Your control for them, and that would be your principles and control as part of your safety program. I'm going to jump into this. You guys have something called guide laboratory practices. Maybe you throw some light on that one. That's what I've been told. Your electrical safety here, St. Paul, R&D, and pilot. Okay, so we handling electrical equipments, circuit and employee protection and training requirement. That's part of your safety electrical programs. Does it make sense for some of you who are in this area? Hazard review procedures is the things that you guys have doing yours. That's part of the things that I was showing you at the beginning. The hazard review is the mechanism to assess statistics and identify safe work practice for your specific equipment, including PPE assess section. So what to initiate a hazard, when to initiate a hazard review. There's a bunch of things, guys, that based on you that you can initiate. I'm going to pick this one. Significant increase in quality of hazard material. Quantity. Restart, scale up. All these will require you to initiate a hazard review area, which is filling that form that I showed you at the beginning. Here's where things are located. Resources. The GLP contain a list of the division lab safety contacts as well as a safety engineer for your building. This is my least information. That's what I've been given these. Anybody can throw more light on that? Well, you guys, some of your managers will be doing that. And so that's basically what I wanted to do, guys, before, so we can jump into our exercise. Any comments? Any questions? Comments, questions? We have 45 minutes to finish our exercise. So for the exercise, if you guys don't mind, I hope I ran it quick through the last ones because I don't want to lose time. We have 3 exercises, guys. So do me a favor, and then we need to do the quiz. So the quiz is going to be done at the end. So if you bring category 2 and quiz. So you should have activity 2 at the top and activity 1. Do you guys have activity 1 and 2? Activity 1, activity 2. So I want half of you, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's what you can do. We can have half of you work on activity 1. So let's have 1, 2, 3, 4 work on activity 1, if you guys don't mind. Those 4, and 1, 2, 3, 4 working on activity 2, and then you will be working on activity 3. Activity 3, guys, does not need a lab, so you can work on activity 3 at any time you want. Okay, so when you're done with 1, jump to 2, please, and when you're done with 2, jump to 1, because I don't have enough modules for everybody. So we work in 2, so if you guys team up together here, together, and then we'll go to the activity. So activity 3, you can work on it. For activity 3, guys, let me go over the activities for a second. So for activity number 1, we have a capacitor and we have an inductor, and we need to verify the voltage on the capacitor and the inductor, and they're right there in these suits behind you. That's activity 1. Activity 2, that's activity 2. Activity 1, we have a GF cell receptacle, and we're going to go verify the voltage across the GF cell receptacle. There are different voltages. There's transformer in there. So that's verifying things by using the tools. Activity 3, guys, if you grab activity 3, you're supposed to pick the right PPE for certain situations. So if you look at activity 3, which you can do without the modules, and with the information that you have. So let me look at the first one. It says, number 1, 208 panel, work on electrical conductors, including voltage testing. If you have a situation where you have a 208 panel, and you need to work on electrical conductors, including voltage testing. Okay. A, what type of arc flash hazard risk category do you need? Is it 0, 1, 2, 3, or 4? B, what is the associated arc rating in calories? Remember, guys, the 1.2 or less, and then 4, 8, 25, or 40. These are your based on the category. And C is, do you need insulated gloves? And D, do you need insulated tools? Does that make sense? So we have 4 scenarios that you are to pick the insulated tools, insulated gloves, and the category and the calories. Am I making sense? How do you do that? If you guys go to page, the 3rd page here, can you guys see that page here? Okay, I'm going to help you with the first one. Give you a hint. The first one. All right, so let's just do the first one. 208 panel, work on electrical conductors, including voltage testing, right? Can you guys see them? Okay, go to this page, the first page that has a table in there. So if you guys look at the top, it says panels or other equipment rated 240 volt and below. Isn't that what we want? 240 or below. All right, go all the way to almost where it says work on energized electrical conductors and circuit parts, including voltage testing. Did you guys find that line? Right, almost in the middle of that one, it says work on energized electrical conductors and circuit parts, including voltage testing. Did you find that? Okay, now that's exactly what the language is. Now go across and you see hazard risk what? 1, thank you. Rubber insulating gloves. Do you need them? Does it say yes?
Yes.
Yes. How about insulated and insulating hand tools? Okay, does that make sense? Now, that's it. Now, what category would that be? If it's 1, you guys go to the page that lists the calories for the categories. Category 1 was what? Anybody remember? In terms of calories. Was it 4? 1 is 4 calories per centimeter. So you put 4 under the calories. Okay? Is it making sense, that sheet? Is that sheet? Which page the calories are? You guys, you have them in one of the pages that we just went through them. Page 22? Okay, thank you. Now we give you a hint too. Page 22. Thank you. Okay, everybody got that? Got that one? Okay. So that's category 3. If you guys want to work on that, and let me start working on the other categories here. So please do that, and let's go energize a few things here.